door locks! Ellie, boot up the door locks!
All the files of the whole park. It tells you everything. I gotta find the right file. Oh, this is it. This might be the right file.
I don't want you on this game right now.
What are you talking about?
You've been on kill 'em up games all day and all yesterday.
It's because my new favorite game.
I don't like it. You know.
This isn't the right file. This might be the right file. This isn't the right file. This might be the right file.
I was laying in my bed last night thinking about that, bro. Like, if I just, like, took a shovel and I just started to dig into my grass, I wonder when I'd hit the ocean, bro.
This isn't the right file. This might be the right file.
Dinosaurs lived a long time ago. They were terrible is it? Don't you know? Some ate plants, and some ate meat, some ate fish, and some ate beets.
Well, hello, everybody, and welcome back to Paleontologizing. There's our soundboard there. Good to have you here. Hello, everyone. Glad you could make it today. Kind of a fun, chill stream, and I hope you're ready for it. Check this out. I
got this camera up and running again. Finally. Holy cow. We might have to do some adjustments here, because this shirt is kind of messing with the sensor. But anyway, welcome to Paleontologizing, especially to anybody who's new. We've got a few new folks today here, I believe. Well, welcome. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. And what does that mean? That means talking...
My own research in paleontology. I work on dinosaurs, obviously, as a dinosaur paleontologist. I study dinosaurs, I publish on them in the scientific literature, I dig up dinosaurs during the summer, and we were live streaming that this summer in Wyoming and Utah, so check out the YouTube page if you want to see some recordings of live dinosaur digs. Those were a ton of fun. And, yeah. I talk about dinosaurs 5 days a week right here on Twitch. So, I'm glad you're here. I hope you stick around. Let me know if you've got any questions, because questions are the bread and butter of our broadcast here. I'll tell you why in a second. Let me turn down this light. We'll see if that helps. That's a bit better. Yeah. If you've got questions about dinosaurs in particular, or about fossils in general, the fossil record, extinction, evolution, the history of life on Earth, the philosophy of science in general, questions about any of those things, don't hesitate to ask them. So yeah. Terrible audio on the alternate camera. Oh, hang on a second, Oscar Juniors. I know what's going on.
Let me turn the audio off on this one. How do I adjust that? Give me a second here. It's being real squirrely.
You should not be able to hear anything from that right now. It's turned off. Hang on a minute.
The bone wall is so thin, it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir. And well, that's what this thing is like.
Gamer L.
Everybody a wonderful good evening and special greets to our at Paleontologizing NR, one in the world.
Thank you, Gamer L, for the 10 months of support. I appreciate that tremendously. Thank you. And by the way, Kevin Paynium, I just spoke with him last week. We actually might be doing an interview with him here on this channel toward the end of the month.
Supporting science outreach here on Twitch.
And Photusmint, thank you so much for those 500 bits. I really appreciate that. I really do. Thank you kindly. Thank you for keeping me here on the air with your support. It means a lot. Anyway, I'm going to go back to the other scene right now, which will activate this camera, and I'll see if I can shut off the audio for that, okay?
If you're feeling a bit cheated, try blaming the dinosaurs.
So, let's try that. Listorian, thank you for that gift sub. I appreciate that very much. Look, 1 out of 40. Good stuff. Here. We're gonna go for it, okay? Plug ears if you have to.
Plug ears if you have to.
Alright, is that better now? Here, is it better now? Better? Fixed. That's so dumb. I have it turned off. I have it turned off on there. Like, it's set to mute output. Monitor and output. Mute. But, yeah. Here, let's adjust our picture here. And hang on a minute. Why is this... Okay, that's working. That's good. Live broadcast, everybody. You gotta love them. All right. And thank you there, Plain Balaclava, for the follow. Welcome to Paleontologizing. We're just going to adjust our picture here real quick. Here we go. Configure video. Let's turn our saturation up a bit. See if we can almost get these to match. That's good enough for now. Yeah. All right. Well, everybody. What are we going to be talking about today? We're going to be going over a little bit of fossil news. We're going to be doing a bunch of dinosaur Q&A. We're going to be talking about some 3D prints as well. This is going to be kind of a freewheeling stream here. But, oh boy, this is going well, and I am excited about that. No one will be able to guess what I'm printing right now, but these are only the first 2 pieces of it. Holy boy. Holy cow. Oh boy. And Dinosaur Dave, hey, I will see you around. Thanks for being here, Dinosaur Dave. Yeah. Yeah. And Zephyr Poet says, is there a way to see all the dinosaurs you've done a deep dive on? Not yet. I'm hoping in the future. I'm working on revamping the dinosaur deep dive thing a bit. And it'd be nice to have all of those going forward on YouTube as separate little videos. But, I haven't had time to really put that together yet. I've been very busy since I got back from the field. And, but man, do we have some exciting stuff coming up. Holy cow. And almost there for a hype train, Photosmith? Yeah, almost at a hype train. We've got less than 2 minutes left to try and, get to a level 1 there. Yeah, and you have a couple in mind? Very nice, Zephyr Poet. Very nice. Well, dinosaur deep dives are going to become even more special in the near future. So I hope you're ready for that. And will it be called Deep Digs instead of Deep Dives since you don't dig dinosaurs? I do dig dinosaurs, Gimpleg. What do you mean? Since you don't dive for dinosaurs? Is that what you meant, Gimpleg? Since you do dig dinosaurs. Oh, okay, I gotcha. No, we might be actually doubling down on the diving metaphor. Even though it doesn't make the most sense. It might be cool visually, so, yeah. Yeah, we're doing exactly the opposite, Okami Kuma. Yes, indeed. Yeah. Anyway, it's great to have all of you here today. I'm glad you could join me, and, let me show you what's on the 3D printer right now. It's a very cool critter. Whoop, Seaborn Show. Holy moly. Thank you for the raid. Welcome to Paleontologizing, Seaborn Show.
Seaborn Show and their 13 raiders are about to get flattened by dinosaur content.
Yes, indeed. Seaborn Show, thank you for that raid, and welcome to Paleontologizing. It's good to have you here. Thank you for joining us. How did the stream go today? Tell me about it. And Victor, or rather Victori, how are you doing? I'm just gonna call you Victor. Welcome, and welcome to Vezel. What's shaking? Mr. Pinkcha, how are you doing? Pinkcha, appreciate you. And a few bits. Holy cow. Those aren't bits, those are gift subs. Thank you very much for all 5 of those few bits. I really appreciate that. Thank you kindly.
Really
Holy moly.
Ukulele with those 5 gift subs.
And if we get to 40 gift subs today, I will play you some ukulele songs. We're already at 6. We are 3/20ths of the way there. 15%. Not too shabby. Yeah. Thank you. Holy cow. My name is Danny Anduza, if anybody just waltzed in who's new. I'm a dinosaur paleontologist. And what's a dinosaur paleontologist doing here on Twitch? Well, I think we can let a friend of mine answer that question. I don't think it's too early in the stream to bring on previously recorded Danny, do you? Seaborn Show, does that sound good to you? I can't read Cyrillics. Not sure what you're saying there, but I'm glad you're here, and thank you again for the raid. How did your stream go? I hope it was really, really good. Without further ado, we're going to call forth a friend of mine. We like to call him Previously Recorded Danny. He is, well, he is eager, very eager indeed, to tell you what this channel is all about, who I am, what a paleontologist is doing here on Twitch, and he's walking up right behind me right now. So we'll let him take center stage.
Hey,
and
living dinosaur.
And Mr. Pichka, thank you. Mr. Piechka, thank you for follow. Welcome to Paleontologizing. Here comes Previously Recorded Danny. He'll tell you what's what. Previously Recorded Danny, take it away.
Thanks, present day Danny. You know, people ask me all the time, Danny, how did you first get interested in paleontology? And I've always been interested in fossils from the earliest time I can remember, particularly dinosaurs. My parents like to say that I decided I wanted to become a paleontologist pretty much the moment I realized I couldn't grow up to be a dinosaur. And believe me, I tried.
I was born and raised in the San Francisco Bay Area, which is a lovely place to grow up. Except that we haven't got any dinosaur fossils here. So right after high school, I packed up and moved to Montana, one of the best places in the world to find dinosaurs. Just a couple days after I arrived in Montana, I started working at the lab at Museum of the Rockies and the paleontology program founded by Jack Horner. Jack's done a lot of amazing things in his career, but you may know him as the scientific advisor on the movie Jurassic Park.
You consulted on that movie.
I did consult on all those movies.
And they said the guy, Alan Grant, was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
But we wanted a credible resource that could back up several theories that we were sort of expounding. And one was that dinosaurs eventually evolved into birds.
And even the word raptor means bird of prey.
And that's something that Jack Horner believes in and could defend if necessary. And Jack Horner became our credibility.
It was in this program that Jack built that I learned how to be a dinosaur paleontologist and how to think outside the box. I've done work at a number of other museums around the American West, helping to prep fossils, design exhibits, and educate visitors. I did a fair bit of eclectic fieldwork in various places, identifying and collecting early Cretaceous dinosaur tracks on the Idaho border, Sphenodontian fossils in the gravelly range of the Rocky Mountains, Cenozoic fishes in western Nevada, but most of my work out in the field was with Dr. Denver Fowler, who is now curator of the Badlands Dinosaur Museum. In all, I've worked probably a few hundred sites throughout the late Cretaceous of Montana, in the Hell Creek and Judith River formations, digging up dinosaurs. Lots and lots and lots of dinosaurs. And from time to time, that work has even garnered some media attention.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
We found its head, we found parts of its armor and plates, and so it should be a new species.
And much like my fieldwork, my research focuses on dinosaurs.
I'm particularly interested in their behavioral functional morphology. All these bizarre anatomical features that certain dinosaurs had, I want to know what they used them for. Right now, I'm working on a study on spinosaurs.
All right, but don't ask me too much about that because it's still a project in the works and I can't give away too much just yet till it's published.
But anyway, a couple years ago I realized that things were definitely headed downhill in Montana. So I packed up and headed back to the West Coast.
And I've become kind of fed up with all the bullshit in academia, so I found myself another job.
I am now a teacher in early childhood education. And let me tell you, it's been a natural fit since day one. Now, given that I get to design the curriculum, my students now know more about biology, classification, and the history of life on Earth than most adults do. I've been helping raise a new generation of young scientists. Then, coronavirus hit. In mid-March, when all the schools shut down in San Francisco, I started holding classes over Zoom, and we picked up right where we left off. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush, because the treasures that I see are rare and ancient things, like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. I realized that I really enjoy teaching remotely. So back in May, I decided to try streaming on Twitch. And here we are.
This is my passion, and now I get to share it with you. And what could be cooler than that?
I believe that scientists ought to be public servants. Ultimately, it's our job not just to make scientific discoveries, but to teach the public about them. That's exactly what I want to do here. Now, because of COVID-19, this will be my first summer in almost 10 years with no fieldwork. I'm trying to look on the bright side, though. It's not all bad. At least I have more time for outreach, and I've got plenty of cool stuff to work on. And if you could throw some support my way by subscribing, I'd be incredibly grateful.
So anyway, if you are new here, you should be pretty well clued in by now. And I'm glad you're here. I hope you're having a good time. Anyway, let's see what present-day Danny has cooked up for us. All right, present-day Danny, back to you.
Well, thank you very much, previously recorded Danny. And thank you, of course, even more to Seaborn Show for that raid. I appreciate that tremendously. Thank you, thank you. And also, did I not yet thank Lordy, who raided during the cold open video, I believe? Thank you, Lordy, for your raid. Can we get a shout out for Lordy as well? If any of you are not yet following Lordy, you're missing out. She was streaming some sewing today, making a pair of shorts, I believe. Very functional stuff. If you're the sort of person who wears clothing, you might want to go follow Lordy. Not only is she super cool and a member of my stream team, one of my favorite people in the world, her streams are also super chill and super fun. So check them out. And Seaborn Show, again, I appreciate the raid. Thank you again for your kind words and for bringing everybody here. It's great to have you. Let me know if you or any of your raiders have got any questions about dinosaurs, about the fossil record, about natural history in general, any of that stuff, you know? Don't be shy. And welcome again to Paleontologizing. Yeah. You've clothes on right now, Retro Roadshow? What are the odds of that? What are the odds of that? Holy cow. Yeah. I can't see you out? Oh, I'm sorry, Arle. But yeah. And thing 1 of 2C says, I'm still studying Silurian marine life. Really? You haven't moved up to the Devonian yet? Still Silurian? That's awesome, thing 1 of 2. Can I get my local museum? So I can get my local museum to go on a dig. Any suggestions for some good resources? What kind of resources you mean, thing? So I can get my local museum to go on a dig. Oh, wait, you mean, like preparation for fieldwork? What do you mean, thing 1 of 2? Rephrase your question. What kind of resources are you looking for? Let me know, and I'd be Thrilled to help you out. And you studied geology. Very cool, Seaborn Show. Geology is one of those sciences that it really changes your perspective on the world around you. There's a certain magic in studying the history of our planet. It's hard to describe, but it's very cool. Yeah. And, Raven's Quarter says, can we get an update on your skeleton printing projects? Ravens, have you seen the full-size Allosaurus skull yet? Because I have that finished. I'd be happy to bring that over for you if you haven't seen it yet. Otherwise, we'll be talking about what's on the printer right now in just a moment here. So stay tuned. We'll talk about that. And you've not seen the Allosaurus yet, Raven's Quarters? Holy cow. Oh boy, are you in for a treat. Here we go. Let me get it for you. And resources to study. Oh, and thing 1 of 2? Oh man, have I got you. Here. Wait just a minute. Let's get this Allosaurus skull out and then we'll talk about fieldwork. Alright, this is quite the thing here. But let me... Here we go. You ready? Take a look at this. A full-size Allosaurus skull, 3D printed. Yeah. Let's get those lights going on in there. Oh, that one's dead. Here, let's pull the batteries out of this one. But this took, I don't know how many hundreds of hours to print. Man, was it worth it. Holy cow. So Allosaurus is the most common meat-eating dinosaur from the Morrison Formation, the end of the Jurassic, the same formation that Stegosaurus and Apatosaurus, aka Brontosaurus, are from. Yeah, get those lights going there. RGB. Yeah, this is, it's so big I have to move it out of the way when I'm not streaming. Otherwise, it's in front of my bookshelf. Can't get to any of my books in my office. But, check that out. It doesn't even fit in frame. I'll switch to another camera view. Check that out. Allosaurus. This was only possible because of the generous support of multiple viewers who not only support these broadcasts through gifting and subscribing and cheering and stuff like that, but also by sending me 3D printer filament from the Amazon wish list. So check that out. Pretty cool, right? Yeah. Very excited about this, if you can't tell. Yeah. It's not even painted yet. It's gonna look even better when it's painted. Yeah. Nice. Yeah. So yeah, and that is 1-to-1 size, SB. Yes, indeed. Yeah.
They were finding fossils.
Smooth Copycat. Ooh, Smooth Copycat. Isn't that a Michael Jackson song? Yeah, you got got by a smooth copycat. I'm not good at singing Michael Jackson songs. Or recognizing them, apparently. Anyway, welcome, Smooth Copycat. Cheers. Good to have you here. Yeah. And There you go, Arle. Speaking as my father, my real father, Arle. You would say that, huh? Yeah. Yep. That's why I keep it on this little cart right here. Because it's too big. This is actually bigger than my bed. Almost. Yeah, and it might chew me up in my sleep, so I keep it pushed away over into the office, you know? Yeah. So anyway, and Ghostly Ghoul says, spooky, scary skeletons send shivers down your spine, like the song goes. Yes, and we'll be talking all about skeletons and skulls next month, prior to Halloween. In fact, we're going to be 3D printing and assembling a human skull. Oop. There's two of me. How did that happen? Here. Go away. There we go.
Rampaging in an unsuspecting world.
And holy cow, Zachap. Zachap.
What havoc will they wreak? What lives will they destroy?
Zachap.
What panic and terror will they create?
Oh no, is that a Zalmoxes there?
Some sweet havoc.
Does anybody remember that part from Prehistoric Planet? Zachap, thank you so much for the raid. Welcome to Paleontologizing. It's great to have you here. Holy cow. How did your stream go? I hope it was really, really good. Welcome back to Paleontologizing. First of all, Zachop, tell me about how your stream went. I want to hear all about it. And let people know in the chat know why they should follow you. What kind of stuff do you do? Thanks for bringing your viewers here. If you're here for the first time, anybody, Raiders, my name is Danny Anduza. I'm a dinosaur paleontologist. You're clever folks, so you probably know already that a paleontologist is a scientist who studies fossils. I work on dinosaur fossils in particular. As you can see here in my office. These are all 3D printed, by the way, and we're printing another extremely important fossil right now. I'll tell you about that in just a minute or two. But yeah. And Truckhorn says, I'm seeing double. 4 Dannys. Oh no. Simpsons reference, Truckhorn. Yeah. That's a good episode. Everybody loves rats, but they don't want to drink the rat's milk. Maybe that was a different episode. Anyway. There were mobsters in both of them. Von Munchausen, how are you doing? Welcome, welcome. Ganja Fairy. Hello, hello. Smooth Copycat. I already said hello to you, but I'm glad you're still here. Yeah. Here, I feel like we've got some more new people in chat. Maybe they should also be introduced to previously recorded Danny, who at this point has changed outfits and locations. This is a different previously recorded Danny. Give me a 1 in chat if you would like to receive another visit from previously recorded Danny to tell you who I am, how I came to be here on Twitch, what in the world a paleontologist is doing on this platform. Give me a 1 in the chat if you'd like to see more previously recorded Danny. There we go. We're getting some 1s. Okay. Oh.
Take the phone to Mommy now. Take the phone to Mommy. It's the dinosaur man.
Okay.
Starwolf, thank you for the 3 months of support. I really appreciate that, Starwolf. Thanks for keeping me here on the air for the past 3 months. And Ganja Fairy, thank you for the follow. Good stuff. I'm not seeing that many 1s, honestly. So, you know what? That's okay. We'll continue with what we were doing here. I know how to read the room. Anyway, we're talking about skulls and skeletons. This is one that I'm very excited to print. Who knows what animal this is from?
And if dinosaurs had not died, I imagine that mammals would still be small creatures like this living in the nooks and crannies of their world, and we wouldn't be here.
Zayday420. Thank you for the follow and welcome to Paleontologizing. It's good to have you here. Yeah. This is from an animal what is called Homo sapiens. And this is going to be a really, really cool model to print because it's an entire skull of this critter held together with magnets. And I received some magnets. From a very generous contributor in chat. This will be almost enough. I'll need to get a few more, but you know what? I can probably afford that at this point. Yeah. So these just snap together like this. There, let's double the speed on this here. Yeah. So it just fits together like that. Snap, snap, snap. It's going to be interesting gluing all these magnets in place, but you know what? I'll make it work. Yeah. But we're going to be talking all about skulls before Halloween because, you know, at least here in the United States, you see a lot of skulls used as decoration. Skulls and skeletons. It's a wonderful opportunity to talk about why skulls are important. And all the different skulls that make up or all the different bones that make up a human skull. And how the skulls of different animals resemble those of humans. How they're the same and how they're different. So yeah. Yeah. Good stuff. It's going to be a lot of fun, and I hope you'll tune in for that. But right now, we are printing a different sort of creature on the 3D printer. And, let me tell you about that one. Or you know what? Let me show you about that one. Zakap says, I got a crash, but have a good one. Thank you again, Zakap, for the raid. I really appreciate it. You sleep well. I'll see you around. Thank you again. Can we get one more shout out for Zakap real quick? Go follow them if their content seems interesting to you. Thank you kindly for, you know, bringing your viewers here. All right. This is the critter that, well, this is a video about it. It's not literally the barrel of a gun, but, you know, you'll see.
It was definitely the biggest adventure of my life.
Ooh. Hey, you're good, Claire. Welcome.
Hundreds of miles away from any settlement. We had a narrow summer window of a few weeks when the weather cooperates just long enough to let us in. If we were lucky, it would reveal a desert landscape with freshly exposed rocks.
Ooh, look at those rocks.
We traveled thousands of miles to find fossils from one of the great transitions of evolution.
If the dinosaurs had not died, perhaps in some catastrophe,
Honeybee.
no reason to think dinosaurs wouldn't still be here, wouldn't still be dominating the Earth.
Thank you for the follow. Welcome to Paleontologizing, Honeybee. Appreciate you clicking that follow button. Let's continue.
The move of vertebrates from water to land.
Ah, yes. The first tetrapods.
We were experienced fossil hunters.
You gotta go higher, Neil.
But now we'd have to learn to become polar explorers.
If you're feeling a bit cheated, try blaming the dinosaurs.
I often do.
National Natural History Museum in New York.
Oh, AMH.
Bought a ton of souvenirs.
Oh,
Let's
very
just
cool.
say they'll have enough funding for a further 3 years.
Wow, Chappie Jenkins.
All my money at people, but when I do, they're doing science.
Very nice, Trappy. Very nice. The American Museum of Natural History in New York is it is a truly beautiful museum, and I'm so glad you got to go there. They've got two different dinosaur halls, a hall of Saurischians and a hall of Ornithischians. I'm sure you saw all of these while you were there. Yeah. I've got to visit here once when I was in high school, actually, and that was a magical experience. Truly incredible. There's the old hall there. This is what it looks like nowadays. Really, really lovely. AMH. There's AMH 5027, the Tyrannosaurus specimen, the one that is on the cover of Jurassic Park, the novel. It's on the Jurassic Park logo. AMH 5027, Jurassic Park. There we go. That is the Tyrannosaurus skeleton there on display at AMH. This is how it was originally mounted. There's the Jurassic Park cover. Yeah. It's, unfortunately, the artist who drew it didn't quite know how to do the, you know, fenestra back here like on our Allosaurus. Whatever, though. It's fine. Yeah. Or the Neris. They also left out the Neris. The, holy cow. Oh, come on. Give me a second here. The window has made its way in a... This is frustrating. How do I... Whatever. It's made its way into like a really weird spot where I'm trying to be able to manipulate this so that you can see it properly. There we go. Ah, that's such a pain. Anywho. The artist who drew the silhouette for the Jurassic Park logo Tyrannosaurus skeleton completely left out the Neris. You know, the nostrils. Right here. So he's... It's like that old joke. You know, my dog's got no nose. Well, how does he smell? Terrible. The Jurassic Park logo T-Rex has got no nose. You ever noticed that before? Yeah. So that's the same guy, Trappy Jenkins. Yeah, you saw him. You saw him. Yeah. Art for Mart's sake. I've never heard that before, Andy. That's really funny. Art for Mart's sake, like marketing. Oh boy. Yeah. It's a dominance display by Windows. Hey, I showed it who's boss. I'm the dominant one here. Yeah. You can't unsee this? Yeah, Reason to go. Every time you see the Jurassic Park logo now. You will see that the Tyrannosaurus does not have a nose. It's got no nose. No nose on the Tyrannosaurus. The nostril, the Neris right here, like on our beautiful Allosaurus. Gone. The T-Rex has no nose. So yeah. Extinction joke. There you go, Nell, yeah. The Jurassic Park T-Rex has no nose. There you go, Trappy Jenkins. Shoot, that reminds me of, yeah. Here we go. Let me see if I can find this for you. Holy cow, they've got... That's nuts. They have, yeah, that's wild. It didn't used to be like this, but it's got chapters now. Is this like a new feature on YouTube where it automatically makes chapters? That's really cool. Anyway, this is a video that I did a long time ago before I ever got on Twitch. Take a look. Well, hey there. This is Paleontologizing. I'm Danny Anduza, and today we've got something pretty special planned. Jurassic Park isn't just one of the most popular films of all time.
It's also tremendously important as a
Let's
cultural
protect our
touchstone.
fossils.
And as a
because if they're removed, America loses them forever.
Tinkarica, thank you for subscribing with Prime. I appreciate that very much. Tasty, tasty Prime sub. That is putting food on my table directly. Thank you, Tinkarica. Appreciate you.
paleontological public outrage.
Yeah.
That's important to understand. After
No closed
all, as a
captions, though.
dinosaur paleontologist,
Shoot.
it's my job not just to dig these animals up and to study them, but also to make sure that information from my science is getting to the public. And like it or not, Jurassic Park has shaped the public's view of dinosaurs for a generation. To help explore this idea, I sat down with one of my favorite people in the world who has somehow managed to have never seen this movie before.
Yeah.
Today
It's
we are
Mariel,
joined by the
friend of mine from
lovely and
Montana.
smart Mariel Colvin.
Hi.
So Mariel, despite being a native Montanan, you were born and raised in Montana, correct?
Yep, 6 generations back.
6 generations, jeez. And yet, you have never seen Jurassic Park, which might be, tell me if I'm wrong about this in the comments, but that might be one of the most prominent films to ever actually feature scenes in Montana.
A river runs through it.
I've never seen that.
You've never seen
I've
it.
never seen
Still never seen that movie. Still never seen that. Years later.
It's not more prominent,
I don't think it is.
but it's also quite famous.
Yeah.
The extinction of dinosaurs is the absolute prerequisite to the evolution of large mammals and to our own existence, for that matter.
Witchy Crafts, thank you for the follow. Welcome to Paleontologizing. Yeah. Anyway, so we watched Jurassic Park together. Here we go. Yeah.
Any questions? We can talk about that. And should be fun. So, you ready?
I am ready.
All right, let's do it.
This is my old apartment back in Bozeman, Montana, where I lived with 3 other paleontologists. You can see our paleontological decorations.
He says, I bet you $1,000 he falls.
1,000 pesos, but yeah.
Dr. Grant, Dr. Sattler, we're ready to try.
That doesn't look like Montana.
It's not Montana. She's right. That was Southern California.
This new program's incredible. A few more years development and we won't even have to dig anymore.
Yeah.
Marielle, you have now seen Jurassic Park. I can now remove you from that part,
Yeah.
that very thin part of our Venn diagram. I'm sorry for that. But first,
Anyway, let's go to this part. There we go.
You know, that does lead us to another question I had.
Here we go. This is why I brought up this video in the first place.
In which I asked you how well a Tyrannosaurus can smell. Speaking of senses.
I want to make it clear to the viewers at home that this was unprompted. You came up with this on your own.
Okay, do you want to know the thought process?
Volume's quite low? Shoot, let me turn it up. I'm sorry.
Okay, so the T-Rex goes and chomps the goat, and for some reason, an entire leg flies off the goat.
Where's the goat?
Ugh.
And lands on top of the car.
On top of the Ford Explorer.
The kids
Yes.
are in.
Yeah.
And then the T-Rex chomps down the rest of the goat.
Yeah.
And breaks down the fence, and I wanted to know
Yes.
whether or not the T-Rex would be able to smell the extra goat leg that had flown off of the goat and landed on the car.
This is an excellent point. And
Hey, Lenina, how you doing? Welcome, welcome.
chances are, yes, I would say absolutely yes. So, one of the things that we do know about Tyrannosaurus, and I have to preface this by saying that we don't know most things about most dinosaur taxa. Most dinosaurs are mostly a mystery to us.
Yeah.
There are a few that are very well studied, and Tyrannosaurus actually happens to be one of those animals that is very well studied. So
It is.
one of the things about T-Rex,
It's got no
is
nose,
they
gonna
actually
sleep well,
happen to
yeah.
have very, very good casts of its brain, and so
Its
we can
brain.
do what we call an endocast, where we basically have a 3D model of its
Yeah.
brain cavity. We can tell how its brain was shaped.
Yep.
And so
shaped like this. I have it 3D printed here.
T-Rex brain that we know is that its olfactory nerves.
He's right here in the front.
Extremely large, like
crazy big.
freakishly large.
Yeah.
Like up there with the greatest olfactory centers in any animal that ever lived, as far as we know.
Yeah. The brain of Tyrannosaurus, you can find one of these and 3D print it online yourself. Let me find this for you. On good old Sketchfab. Tyrannosaurus brain. There you go. There is an endocast of AMNH 5117. Different Tyrannosaurus specimen than the one that we were talking about, but yeah, there it is. This is a T-Rex brain. These things coming off of it, these projections are different nerves. So these are nerves or veins. The transverso-occipital vein, transverso-geminal vein, ophthalmic nerve. This one goes to the eyeball right here. This is the one that goes to the eyeball right there. Anyway, over here, that is the olfactory bulb right there. So this is a huge smell center on this animal. This is like the primary way in which Tyrannosaurus experienced the world was through smell. It had very, very good eyesight, too. Incredible eyesight. Almost like that of a bird of prey. But its nose was, holy cow, was it incredibly acute.
This is a dinosaur, and this is a dinosaur too.
That first one was a dimetrodon. That's not a dinosaur. But welcome, Cookie Robert 666 anyway. Welcome to Paleontologizing. Thank you for the follow. Good to have you here. Yeah. I didn't know we had casts of their brain. We do indeed. Yeah. When you've got a well-preserved dinosaur brain case, you can scan it in a computer and look at the hollow space inside and figure out what the animal's brain looked like. I wonder if I can find you a good video about this. Yeah. Well, shoot. Here's Larry Martin talking, or excuse me.
Hi.
Larry Whitmer. Wrong Larry. Different paleontologist Larry here. This is Larry Whitmer. Larry Martin died a number of years ago. He was one of the birds are not dinosaurs people. Interesting guy. Larry Whitmer is at the Ohio University in Athens, Ohio. And he works on scanning dinosaur skulls and the skulls of other animals. He's particularly interested in the brains of extinct animals, and here he is to talk about that.
Hi, I'm Larry Whitmer, and welcome to another Random Act of Anatomy. We got Triceratops today.
Oh, yeah.
The reason we're doing Triceratops is that our team is going later today to Bozeman, Montana, in the Museum of the Rockies.
Where I used to work. Holy cow. Which specimen are they looking at?
To study dinosaurs of all different kinds.
Okay.
We're also going to be returning specimens, such as this brain case of Triceratops right here.
Ah.
This specimen right here is another specimen of Triceratops from the Museum of the Rockies, MOR 699. It's all in pieces.
699. Who is that? MOR 699. MOR 699. Triceratops. Who is that? MOR 699. Is it one of these guys? That's not Juvie Trike 3, is it? I'm not sure. The thing is, we've got like 100 Triceratops specimens at Museum of the Rockies. I'm not sure which one it would be. This looks like Yoshi's trike right here. It's not going to be Yoshi's. I don't know. let's continue.
And I got it laid out here for you. Part of what I want to show you is that this looks like a pretty big animal. And
That's a juvenile, though.
The brain case of this specimen of Triceratops right here. Here's the occipital condyle where the neck attaches.
Yep.
What I want to show you now is the brain case that we're returning, MOR 1194. And so here's this brain case right here. This is all we have of this particular specimen on loan.
Oh, and shoot, I missed your question, Young Black Economist. I'm sorry about that. Darn it. But we've got some wonderful moderators here, including champion the Lenina. Lenina, thank you. Yes. We don't know if Tyrannosaurus itself had feathers, but we do know that other tyrannosauroids, other like ancestors, early examples of tyrannosaurs earlier than T-Rex did have they did have feathers. We've got preserved feathers, in fossil form for them. Creatures like Dailong and Eutyrannus from China. So there is a good chance that Tyrannosaurus had feathers when it was young, but we don't know if it had feathers when it was full grown. We're not sure yet. Thank you for your question. It's good to have you back.
Here is the occipital condyle right here. What we can do is compare the occipital condyle of the specimen that we see back here.
By the way, the occipital condyle is at the back of the skull. It's like the ball and socket joint that connects the skull to the backbone. So, here, let me show you here on our Allosaurus. Wheel this around. And this right here, see, this is almost just like a trailer ball right there. This is the occipital condyle. So this is what attaches to the backbone right here. And it's like a, like a ball and socket joint. Right there, occipital condyle. You got that? Good.
And look at the size difference. This one is much smaller. The Triceratops that belonged to this thing right here must have been an enormous animal. Well, tell you what, let me put this thing down here. I'm on my own here, so let me just zoom in here a little bit so that
I can relate. One-man show here.
Better. Whoops, wrong way. There we go. Okay.
No. Hey, I am a public servant here, Young Black Economist. All questions get answered if they're good questions, if I spot them.
Because if they're removed, America loses them forever.
Thank you. Thank you very much for subscribing. From the bottom of my heart, thank you for your support of this channel. Thank you for supporting my research and outreach and fieldwork. Thanks for subscribing. I appreciate you very, very much. Thank you, thank you. Yeah. Then you go and sub. Yeah, there you go, Claire Burr. Young Black Economist, I appreciate you. Thank you very much. Welcome to Paleontologizing. Welcome to the community. It's great to have you here. Yeah.
So we can see the brain case right in here. I'll spin it around a little bit. You can see.
Look at that.
Really
huge occipital condyle.
Brain would sit in here. And part of the
I'll spell that out for you in chat. Occipital condyle.
See if we could figure out what the brain was looking like. Well, let me just go ahead and pull this up here so you can see some of the features.
There you go.
It's actually a pretty nice brain case. It looks kind of beat up, actually. Like there's lots of fractures, but we can still see lots of these big holes in here. If you look on the back right here, you can see that.
The foramen magnum. Yeah.
Cord would come out. Here's the right side right here. So the front's that way. And you can see lots of these little holes right here.
Yeah.
So what we did, as we typically do, is we ran this thing through a CAT scanner, came up with the digital endocast, and in this case, we printed it out. So here's the
there's a Triceratops brain
that goes with this guy.
That's so cool.
The blue part is the brain part.
Oh boy, these red parts right here that are kind of loopy looking on either side. Does anybody have an idea what those are? What are these like circular things on either side like this? It almost reminds me of like a spirit level or something like that. Any guesses? What might that be? Well, let's let Dr. Whitmer explain this for us. But we had several correct answers in the chat. You know who you are.
More or less. The yellow are the cranial nerves. The red things are blood vessels, arteries, and this color right here is actually veins, and that's the inner ear right there.
That's the inner ear right there, and we can see that on our Tyrannosaurus as well. We got the inner ears right here, the semicircular canals of the inner ear. That was probably the term that you were searching for, Lenina. I couldn't even remember it on the spot. Semicircular canal. So, like, if you or anybody you know has ever had vertigo, it's like sometimes a problem with your inner ear where you kind of lose your sense of balance. Because the semicircular canal, as I understand it, it's got little air bubbles in it. Like, in some fluid in here, in that canal, in your inner ear. And this is what kind of gives you your sense of balance. And so, if you've ever used a spirit level before, you can use this to measure the angle of something. You've basically got two of those inside your skull. Or in your head, at least. And, those are what allow you to maintain a sense of balance. Tyrannosaurus also had this, the semicircular canal right there. So did Triceratops. So do pretty much all tetrapod animals that I know of. There might be some exceptions, but this is like a standard issue feature if you're an animal that has bones that lives on land. If you're a tetrapod, this is what you've got, you know? It's like a level. Exactly, Betmendler. Yeah. Yeah.
One thing we can see here, and let's not judge.
And Lenina says, that's why spinning makes you dizzy. Yeah, because it keeps sloshing around. Yeah.
Triceratops. But this is a really small cerebrum. This brain case isn't so distorted to suggest that this is strongly compressed. I think Triceratops just simply was a fairly simple animal. Probably not a lot of cognitive capabilities. But one thing we can see
wasn't a super genius or anything.
All of these
didn't need to be.
Openings here in the brain case match up with features in the endocast. So this opening right down in here is actually where blood entered the brain. This is the carotid artery, the cerebral carotid artery. And these other things are basically cranial nerves. This opening right, or this structure right here, is something that would have emerged through that hole. That's part of the trigeminal system, the maxillomandibular nerve. This piece right here is another part of the trigeminal called the ophthalmic. And we might have missed it by just looking at this, but using the CT scans, we could see how this nerve tunnels through and actually emerges right around.
Very, very cool.
And we could do that with all of the rest of these nerves, and you can sort of see that we get a very complete endocast as a result.
This is so cool. I mean, holy cow. Larry Whitmer in his laboratory, they are at the forefront of this kind of science. If we have anybody from the Midwest, from Ohio in particular, you should be very proud that someone in your home state is at the bleeding edge of this kind of science, figuring out how dinosaurs would have lived based on the shape of their brains like this, gaining insights about, you know, dinosaur paleobiology by looking at endocasts. This is deeply, deeply cool stuff. And, you know, I know sometimes Ohio gets a bad rap. Sometimes it's deserved. But any Ohioans here in chat? Holy cow. This laboratory in Ohio is leading the world in this kind of work, which is super, super cool.
And we could do that with all of the rest of these nerves, and you can sort of see that we get a very complete endocast as a result. And so we kind of got to get moving here, because I got to get this guy packed up. We're hitting on the road in just a couple of hours.
I love this. He took the time to do a video, though. This is wonderful. I'm going to share this with you right now after I like it. There's the video in the chat. Whitmer Lab does some really awesome stuff, and some of the 3D prints that I have here in my office are because of Whitmer Lab. I really need to contact Dr. Whitmer and ask about getting a copy of that Triceratops endocast, because that would be super, super cool to be able to print.
But before I did that, I just wanted to show you what this brain case of this huge individual of Triceratops looked like, as well as giving you a glimpse of its brain endocast. So with that, I'm Larry Whitmer, and thanks for seeing another random act of anatomy.
Good stuff. Good stuff. I need to subscribe to this channel. Whitmer Lab. Yeah, that's from 6 years ago? Holy cow. Wait, 6 years ago? 2023. I would have been in Montana at the time. Yeah. Shoot, I may have actually run into Larry after. Like, on this trip, actually. Yeah. Yeah, good stuff. Anyway. Wait, we were talking about Tyrannosaurus and Tyrannosaurus brains. So there we go. Yeah. And also a very good school. Just lost the lawsuit of being the Ohio. Really? Are they no longer called the Ohio State University? I always made fun of them for that. Because in all of their videos and stuff online from the university itself, it would always say, oh, yes, the Ohio University. The Ohio, no, not the Ohio State, that's the Ohio University. Ohio State is in another, it's in another place. Yeah. But yeah, and Rebeccasaurus, Matt M33, we'll cover that today, later on. Good stuff. Anyway, back to Tyrannosaurus brains.
Happen to be extremely large, like freakishly large. Like up there with the greatest olfactory centers in any animal that ever lived, as far as we know.
Yeah.
So I gotta, you know,
Nuts.
like we don't really have endocast of a lot of dinosaur brains, but we have it for Tyrannosaurus, and it happens to have huge smell centers in its brain. We know this animal had a tremendous sense of smell.
Yeah.
So, yeah.
By the way, the olfactory center in your brain is probably like the size of a grain of rice or something, I'd imagine. I don't know. Look at how big they are on this animal. It's nuts.
Chances are it would be able to smell that goat leg on the top of the car. Probably. Yeah,
so that on top of the light that she turned.
I mean, that's attracting the animal to that car visually. It probably would have been attracted to that smell anyway. I mean, I don't know. I'm not an olfactory scientist. I don't really understand how smells propagate throughout different environments, especially if it's like a tremendous Costa Rican downpour. But
that's fair.
Yeah.
Is the whole thing about it can't see you if you're not moving?
Don't move. Can't see us if we don't move.
Yeah, this part.
A gimmick or likely?
That's probably bullshit. Yeah. So, I mean, when you have a Hollywood film...
Make sure they'll be able to survive.
Yeah, you can't have all of your characters being eaten by dinosaurs. As much as somebody like me might enjoy seeing that, just seeing more screen time from the dinosaurs, frankly. I mean, you have to have some of your main characters surviving. And I really can't complain that both of the paleontologist characters in this film happen to survive. And
There you go, young black economist. Yes, yes, indeed.
You know, bite the dust in a pretty cool way. Yeah, I can't complain about that.
Pretty cool way.
Well,
It's eaten off of a toilet.
Yeah,
At least his pants are up.
Anyway, there's that. Man, that was a lot of fun. But the thing is, in the Jurassic Park logo, the Tyrannosaurus has literally got no nose. There's no nares right there. The nostril is not present, which has always made me laugh. It's hard not to laugh when you see this image. because of that. It's... And then whatever is going on there with, you know, this bone right here, yeah. Anyway. Yeah. And Lenina, thank you for reposting that from Megan Nanem. It says, how big was a Stegosaurus brain? Remember an older book saying it was the size of a walnut. Is that still true? No. It's the size of, like, several walnuts. The thing is, Stegosaurus. Stegosaurus has got a very small head. This is not an animal that's got a very large head. Its brain is not particularly big. It, for whatever reason, evolved a very, very small head. And I'm working on 3D printing I will 3D print a Stegosaurus skull at some point. I have one printed already, but it's way too big. I need to redo it. It's not very helpful as a visual aid, I suppose. But the brain case of Stegosaurus is very small. This is not a particularly brainy dinosaur, but it didn't have to be. This group of animals, the Stegosaurus, survived for tens of millions of years, and they thrived. They're some of the most common dinosaurs in certain formations in the Jurassic period. They were very good at whatever they were doing. And so even if they were, you know, not super geniuses, they were clever enough to get by. Holy cow. They survived for a lot longer than we have so far as humans, and if current trends continue, Stegosaurs will have been on Earth for much longer than humans ever have been. We might not be around for very much longer if we continue to mess things up here on our planet. Anyway, yeah, the brain of a Stegosaurus is probably the size of like 3 or 4 walnuts, I would imagine. But it's not big. It's not big. But saying, oh, it had the brain the size of a walnut, no. Probably about the size of a tennis ball or something like that for a large Stegosaurus. So, yeah. Yeah. And Jake programming is a mammoth dinosaur. No, a mammoth is an elephant. And elephants are a kind of mammal. Yeah. Here, there we go. I thought I had this bookmarked. So mammoths are a kind of mammal, which are very far indeed from dinosaurs. So let's do a search here, shall we, on our grand tree of life. Is it not letting me? This used to be search. This is always a little buggy. And it's gonna be buggy today too, apparently. Maybe they got rid of that feature? I don't even know. Refresh the page, we'll see if it works. You used to be able to click these. Let me show you another one. This is what we call a phylogeny, an evolutionary family tree. And this shows what are dinosaurs and what are not. That's the purpose of this one right here. I'm going to go ahead and annotate this with my trusty draw pad and stylus. And so, yeah. What is a dinosaur and what isn't? So dinosaurs they start off right here. So to be a dinosaur, you have to evolve from this ancestor here. So all of these guys are dinosaurs. And you'll notice that includes birds as well. Birds are dinosaurs. Mammals are not dinosaurs. So mammals are creatures like you and me. That is mammals right there. Mammoths belong on this branch here. So they are not dinosaurs. Dinosaurs are a very specific group of reptiles. A lot of people kind of get the impression that, like, oh, dinosaur just refers to... That word refers to a group of animals that lived a long time ago, and they were big and weird and cool. There were lots of big, weird, cool things that lived a long time ago, even during the age of dinosaurs, that weren't dinosaurs. Dinosaurs are a specific group of animals. And it's everything that evolved from this ancestor right here. That's what a dinosaur is. And so it's kind of funny. There's like a definition of dinosaurs that you can go by. And we can illustrate it right here. So a dinosaur, if you want to get technical about it, use a cladistic definition. A dinosaur is any creature between Triceratops, modern birds, like the house sparrow is usually the one that's selected, and all descendants of their recent common ancestor. So, there we go. So that basically means all of... Here, let's do this in blue. The ancestor of Triceratops, the English sparrow, and all of the descendants of that ancestor. These are all dinosaurs. Anything that does not fit that definition is not a dinosaur. Does that make sense? I hope it does. Yeah. So yeah. Yeah. Anyway. And pterosaurs are not dinosaurs, are Kamikuma. No, they are not. Yeah. Shoot. Show you again. Pterosaurs are close to dinosaurs right here. See, but dinosaurs begin here. These guys are not dinosaurs. They're close, but they're not dinosaurs. Yeah. Think of them as very, very close cousins of the dinosaurs. Yeah. So yeah. Yeah. Can't help but notice some of those node branches are empty of a specimen. I don't know what you mean, Makeaway. What? Node branches are empty of a specimen? I don't know what you mean. But yeah, and where is that? Let me give you a link to it. You can actually buy a poster of this. It's super cool. Good stuff. Yeah. And I like how it even shows you what's kind of uncertain. So dinosaurs, not dinosaurs, contested placement, and a group with living members has got a leaf on it. So, birds are still around. They've got a leaf. Crocodiles still around. They've got a leaf. Turtles, they've got a leaf. Mammals have got a leaf. Various groups of lizards and snakes, they've got leaves. But all the rest of these critters are extinct. So yeah. Yeah. Cool, right? Yeah. Anyway. Yeah. And Jake Programming, wait, was asking about marine reptiles or something? Let's see here. We talked about this yesterday, too. Did humans evolve after dinosaurs died? Yes, not just after the dinosaurs died, but like 63 million years after the dinosaurs died, humans first evolved. A long, long time after. Yes. Yeah. Except for birds. Birds are still living dinosaurs, but if we're talking about non-bird dinosaurs, like what everyone thinks of when we talk about dinosaurs, you know, dinosaurs like this. They died out 63, maybe 64 million years before the first humans evolved. Does that make sense? And shoot, there would have been no humans if there were still these kinds of dinosaurs running around, because these kinds of dinosaurs were running around for like 170 million years, while our ancestors, little mammals, little shrew-like mammals, they were doing their thing. They stayed small for the entire age of the dinosaurs, while these guys were around. It's only after that asteroid hit and wiped out these guys that our ancestors finally got bigger than about like this. All of the mammals, the very largest, most gargantuan mammal during the age of the dinosaurs was about this big. Most of them were like this. It's only after the extinction of the non-bird dinosaurs, like these guys, that mammals really went anywhere. Went anywhere in terms of size. It involved some interesting morphologies and stuff, but they were very small. Yeah. So yeah. Peter Steve says, time to take over the world now. Yes. Yes, Pinky. We'll do what we always do, or however that goes. Man, that would be a great clip to use, actually. Shoot. Oh. And yep, thing one of two. Pterosaurs are cousins of dinosaurs. And that reminds me, thing one of two, I didn't answer your question yet about preparing for fieldwork. The best resources that I can give you for preparing to do paleontological fieldwork, thing one of two, they're mostly like, it sounds dumb, but they're mostly mindset kinds of things. There's a book that I'd like to share with you. See if I can find it on Thrift Books. Get it for you cheap. Yeah, there we go. Ooh. Very nice. The best book that I can recommend to you, thing one of two, is this one right here. This is one of my very favorite books ever written. It's a book by Michael Novacek called Time Traveler. This is, yeah. I got this book for my 10th birthday, I believe. My dad got it for me. I think he saw a review for it in the New York Times, and he's like, I should get Danny this book. This is a fieldwork autobiography by Michael Novacek, who is a paleontologist from the American Museum of Natural History in New York City. He has done a tremendous amount of fieldwork over the years, digging up dinosaurs and ancient mammals and proto-mammals and all kinds of cool critters. Like he says in the subtitle, from Montana to Mongolia. And he gets into a lot of trouble in this book. He almost dies multiple times. But if you want to find out what life is like in the field, what it can be like, get this book. It reads like an adventure novel. It's really, really excellent. Time Traveler by Michael Novacek. You can get it here on Thrift Books for like $5. It's good stuff. Or better yet, go to your local independent bookseller, call them up, and say, hey, I'm looking for this book, Time Traveler by Michael Novacek. They'll find it for you. Yeah. One of my favorite books of all time. Novacek is a gifted writer. The writing style is totally unpretentious. And yet, you don't even realize that you're learning when you read it. It's pretty awesome. I wonder if we can find a video with Michael Novacek. Yeah. Here we go. Here he is. I don't know if his writing style will really come out in this, but he's a very cool guy.
UCLA, who was a paleontologist. I guess what I said at the end of that field season is, oh, you can do this for a living? This is amazing. When you've been looking in the field so many years, and even when you're successful, you might look for many days or many weeks and find one or two fossils and feel like you've accomplished a lot. Sometimes you'll have an expedition where you don't find anything.
This is good advice for you right here, thing, yeah.
Time, as we did in Yemen many years ago in the Arabian Peninsula.
That chapter is a hoot. Oh, that's one of my favorite chapters in the book, is when he went on this paleontological expedition to Yemen. They didn't find anything. But the mishaps and adventures they got into, it read like a pulp adventure novel to a young aspiring scientist like me. It's incredibly engaging stuff. It's really, you need to get this book.
We hardly found anything there, and after much 6 weeks of work. So after all that work and all those years, to really strike it big is
Thank you, what is it?
Skeptical that you've actually accomplished this.
Cheers.
It doesn't quite seem to be believable. I do love the vast openness and the beauty of a desert. I'm a desert kind of person.
Me too.
You know, I always say paleontologists don't like trees because they block the view. You know, they hide the rocks. So deserts are great places.
I like trees,
and
but
Mongolia,
deserts are
especially
beautiful.
Where I'm working now is fantastic. And we've actually worked there now over 20 seasons. So we've been there a long time. We were the first Western expedition to come in there in the early 1990s after many years. Because
in fact, I think we can find video of that too. Let's see, where is that old documentary? Let's see. Here we go. Yeah, from National Geographic.
They don't exactly look like scientists. Often they're mistaken for each other. But Mike Novacek leads the expedition along.
That's him, author of the book. Yeah.
They could be taken for surfers, but they're from the American Museum of Natural History. Scientists piecing together an ancient jigsaw puzzle of evolution and extinction.
To me, it's so obviously important. I'm so emotionally bound up.
What does a scientist exactly look like?
Imagine
Like this. This is what a scientist looks like. Grilled Pikachu. You know, or like this, you know, upright walking, bipedal, usually only 2 legs, usually only 2 arms. Although that might vary a bit. Yeah, kind of mobile shoulder joint. Yeah, something like that. Yeah.
Emotionally bound up. Our history of where we come from isn't important to a human experience. Could you imagine what it would be like to live in the late 20th century and not know that extinction actually existed?
There's also just a sense of discovery. I mean,
There's another scientist right there.
Something about how the world was 80 million years ago, which is pretty neat. Just having a sense of history.
I'll give you a link to this too.
Gone through, I think, just increases our appreciation for our own existence.
There you go.
Mike and Mark are about to journey to the sun-scorched Badlands of the Gobi. It's a desolate area. a 500,000
I'll go to the
dusty
Gobi
square
Desert someday.
miles of sand, scrub, and
Holy
red
cow.
rock cliffs.
Yeah.
But it's a paleontologist version of heaven.
Oh,
For this
is it now?
where the oviraptors lived and died, and lay untouched in the earth for millennia.
Very cool stuff. Anyway, you got the link in chat now if you want to watch the rest of that. We've watched this on stream before, but excellent book. You can get it for less than $5 on this website here. I promised you I do not get any money from this. I just want to find you a good deal. Keep a book out of a landfill like that. I could give you an Amazon affiliate link and make some money off it, but... You know what you should do is call up your local independent bookseller and say, hey, I'm looking for this book. It's called Time Traveler by Michael Novacek. That's what you should do. Or get it online if you don't like make phone calls. That's cool too. But yeah, what were we talking about here? Oh yeah. What are we 3D printing right now? Shoot. Let's talk about what we're printing right now. Let's go back to the beginning of this video. Shoot. We were like a minute into it. This is what we're printing right now. Not a gun. I'm not 3D printing a gun.
The biggest adventure of my life.
Uh-oh. This is what they needed for fieldwork there. Sometimes you need a gun for fieldwork on rare occasions if there's polar bears.
This was the Canadian Arctic, hundreds of miles away from any settlement.
Sand fog. Interesting, Patrick Crusader.
We had a narrow summer window of a few weeks when the weather cooperates just long enough to let us in.
Sometimes fieldwork is done in remote places that are only accessible by helicopter.
Freshly exposed rocks.
Not the coelacanth, no, sculpin. Something
To
else.
find fossils from one of the great transitions of evolution.
Related to a coelacanth.
The move of vertebrates from water to land.
Yeah.
We were experienced fossil hunters,
You gotta go higher, Neil.
but now we'd have to learn to become polar explorers.
Finding... Wait, don't look at that part. No. What is this critter?
This part of the Arctic has rocks of the right age and the right type to hold evidence of a great transition, when our ancient fish ancestors moved from water onto land. It's hard to believe when you look at this frozen landscape that once this was a warm, watery world swimming with life.
This valley, 375 million years ago, was a giant floodplain. And that floodplain was filled with rivers that swelled their banks and sometimes shrunk, but in those conditions formed swamps and streams of all different sizes. And inside those streams was diverse life.
Yep.
And somewhere out there, our distant relatives sank into muddy graves, which would preserve them for 375 million years.
Mm-hmm.
At the end of our stay in 2000, we found a hill loaded with fossils. And over the next 4 years, we dug, hoping to find the fossils we were looking for.
Well, it was the second week of July in 2000.
There you go,
We're all
Truckhorn,
working
yeah.
in series in this hole, you know, where my head is right next to Farish's feet. And Farish's feet is next to Steve Gatesy, and we're digging together. And Steve says, "Hey guys, what's this?" Ted and I go running over to see what Steve was referring to. And what we saw was this V here. It was covered with rock.
Oh
And
boy.
as soon as we saw
That's the same... That same V that I am printing right now. Oh boy. Yes.
and we saw these teeth under it, it became very clear that this little V we're seeing is the tip of a snout, and that this was a snout of a flat-headed fish.
Based on
yeah.
other fossils from slightly younger rocks, This feature alone suggested we might have a transitional fish.
Okay, we get home. We knew we had a flat-headed fish, but how much of it did we have? Then about a month and a half goes by, and they start to find the orbits, the eye holes.
Yeah, so they're chipping away rock from the specimen in the lab.
And then we see the fins. And then we see more and more and more and more until we see pretty much the entire top side of the body.
This is what I'm printing right now. Tiktaalik. So I'm printing the snout currently in 2 different pieces, but they're building up like that. So in a few hours, I will have a Tiktaalik snout right there. Most of the skull. Very excited about this. Very excited about this.
So you can not only say, okay, what did this animal look like, but we can begin to ask, how did it work?
It'll look like that
move about
when it's printed.
375 million year old streams.
Yeah.
The local Inuit people came up with the name Tiktaalik for our fossil. It means large freshwater fish. But although this creature had the scales and fin of a fish, it also had the flat head and rotating neck of a land animal. And when we looked at its fins, we realized it had the beginnings of the bone structure that's shared by all 4-limbed vertebrates today.
Pretty awesome.
It had versions.
By the way, I might be able to print that too. The like bone structure of this animal for, if I'm able to finish this on time, maybe I'll print that also to use as a nice little diagram. It's super, super cool. What you're viewing here is the origins of your forelimb,
Are you a fan of dinosaurs? I won't get angry if you aren't. What?
Buddy Head, thank you for the follow. Welcome to Paleontologizing. Good to have you here. Your limb that you have right here is descended from the limb of Tiktaalik and similar fishes like this. Where you've got humerus, radius, ulna, carpals, metacarpals, and phalanges. That's all present here in this fish.
By all 4-limbed vertebrates today. It had
Pretty cool.
versions of an upper arm, forearm, even parts of
High five indeed, Grilled Pikachu, yeah.
This was a fish from a pivotal moment in evolutionary history. Descendants of fish like Tiktaalik would go on to spawn reptiles, mammals, and eventually, us.
Yep. Pretty neat stuff. And this is what I'm 3D printing right now. I am pretty excited about that. Yeah. So we'll be continuing to print this for the rest of the week. Tomorrow and Friday and maybe into the weekend too. But we'll be talking a lot about this toward the end of the month. Because on September 26th, which is my birthday, we'll be having a special birthday stream. But that week, we'll also be talking about an important anniversary, the Kitzmiller versus Dover trial. Let's take a look at that real quick. We'll be watching this documentary again.
I believe there is an intelligent design. In the beginning, God created.
Saying that you don't believe in evolution is almost saying we don't believe that the Civil War ever took place in the United States.
An extraordinary court case ignites a small town.
Courtroom drama.
Within the community, there's no question.
Anybody here into courtroom dramas?
On trial.
Very important things were at stake. One is the future of science education in this country.
Nova reveals the story behind the headlines.
Anywhere you turn,
Did you ever,
we're getting...
though, have a moment where it was kind of heartbreaking? I'm
No.
destroying, never.
No, glue is cheap.
Well, I guess I'm here to stay.
GQ, thank you so much for the 2 months of support. I guess you are here to stay. Thank you for keeping me here on the air for the past 2 months. I appreciate you. Welcome back. Good stuff. Yeah. Yeah, here. This is what we'll be talking about at the end of the month on the anniversary of the Kitzmiller versus Dover trial. Important stuff.
The future of science education in this country.
Nova reveals the story behind the headlines.
Anywhere you turned, we were getting attacked.
Witnesses started dropping like flies.
And probes the question, is intelligent design a scientific alternative to evolution?
Spoiler alert, it's not. It's just, as has been said many times, intelligent design is creationism in a cheap suit. We'll be talking about why. This is one of the best documentaries you will ever see on, well, in a, courtroom setting or in, a scientific process. It's good stuff.
Properly the subject of a science class.
Or religion in disguise.
It's a violation
That one.
of everything we mean and everything we understand by science.
Judgment Day. Intelligent design on trial on Nova.
So we'll be watching this probably September 27th, I think, is when we'll start it. Or maybe the 25th. We'll see. But, yeah. Good stuff. And Tiktaalik makes an appearance in that. That's why we're starting our Tiktaalik right now, so we can have it done by that time. And we can talk about this remarkable animal. And there is even a paleontologist who appears in this documentary. Kevin Padian right here.
Does it play by the same rules?
If you invoke a non-natural cause, of science sucks,
After the further
educations and
on those
one from
Where's the part with Kevin? Hang on a minute. Let me find this real quick. I think... Oh, there's Tiktaalik right there. We'll be talking about that later on. Yes. Well, let's just watch this part here. Shoot. Here we go.
Which live part of their life
between fish.
We got to rewind a ways.
Act of an intelligent designer, i.e. God. That's the view that intelligent design promotes.
So how could scientists be so sure Darwin's tree accurately represents the history of life on Earth? As it turned out, the latest in a large body of evidence to refute intelligent design and support evolution was coming to light just as this case was unfolding.
I mean, that's not what Neil Shubin was trying to do. He's just trying to be a good scientist and find cool fossils, but it ended up being important for this too.
Because it's just so beautiful.
Darwin believed that evidence for his idea of common ancestry would be unearthed in the form of transitional fossils.
And hang on a minute. Wait. Did I miss this? Scrolling. Where was this found again? In the Canadian Arctic, Okamikuma, way up north in Canada. Yeah. Anyway, people were talking about their teachers, espousing creationist beliefs in class. I had some teachers who did the same thing. My biology teacher in high school. Man, I could tell you stories. Sometimes I would just get up in the middle of class and walk to the principal's office, and he'd be like, "Oh, welcome back, Danny." I'd be like, "Yep, I'm back." Anyway, yeah, let's continue.
For example, if over millions of years fish gave rise to land animals, as evolutionary theory predicts, we should find fossils of extinct creatures that are part fish and part land animal. In 1999, paleontologist Neil Shubin
and Tonko Trujillo, hang on a minute, says, I saw a Kickstarter for a small dinosaur museum a while back with paleontologizing growing such a steady 3D printer design. Is it a terrible idea to suggest a paleontologizing Kickstarter for a small building with this great little collection? Tonko Trujillo, I have tentative plans for just such a thing. stay tuned, because we might have something like this arising in the not too distant future. You stick around and you'll see. That's all I'll say right now. Yeah. Welcome back, Taco. It's good to have you here. We can do it, Lenina. I think we can. Maybe not a museum as grand as this, but, you know, gotta start somewhere. Gotta start small.
Shubin and his colleagues set out to find just such a creature.
What evolution enables us to do is to make specific predictions about what we should find in the fossil record. The prediction in this case is clear-cut. That is, if we go to rocks of the right age and the rocks of the right type, we should find transitions between two great forms of life, between fish and amphibian.
Many scientists think life began in the water at least 3.5 billion years ago.
Yep. Hey, freelancer, welcome.
More recently, about 375 million years ago, the tree of life branched as primitive fish evolved into amphibians, such as today's frogs and salamanders, which live part of their lives on land. Armed with this prediction, Shubin and his colleagues organized an expedition to one of the most desolate places on Earth, the Canadian Arctic, about 500 miles from the North Pole, where rocks of just the right age are exposed.
It's pretty close to the North Pole.
Here, they hope to fill a gap in the branch of the evolutionary tree that leads from primitive fish to animals with 4 limbs, or tetrapods.
And we already have a bunch of critters that kind of fill this gap already. But Tiktaalik was really important, though. I don't want to denigrate that.
By finding a fossil of an animal that shared characteristics of both.
Yeah.
But after 3 summers of digging through hundreds of tons of rock in this harsh environment, they had found little of interest. They returned the next year for one last try.
Ooh, boy.
Money was running out. This was it. We were told this was our last year up there. And then in 2004, in the 3rd day of the season, a colleague of mine was removing rock and discovered a little snout sticking out the side of the cliff, just like exactly like this. And he removed more rock and more rock and more rock, and it became clear that this was a snout of a flat-headed animal. And that's when we knew, flat-headed animal at 375 million years old, this is going to be something interesting.
Oh, yeah.
They called it Tiktaalik, which means large freshwater fish in the language of the local Inuit people. And it's one of the most vivid transitional fossils ever discovered.
Beautiful.
Showing how land...
Again, what we're printing right now. Oh, man, I can't wait to show you this tomorrow when it's done. Ah, it's going to be great.
Animals evolved from primitive fish.
Over here you have a fish.
Thank you, freelancer. Welcome, welcome.
Years old. And what you see, just like any good fish, it has scales on its back and fins.
That's a coelacanth. I'd love to get a file of that so I could print it.
You find a creature that doesn't have scales, and it's modified the fins to become limbs, arms and legs. And the head's very different. It has a flat head with eyes on top and a neck. What we see when we look at the fossil record, at rocks of just the right age, is a creature like Tiktaalik. Just like a fish, it has scales on its back and fins. You can see the fin webbing here. Yet when you look at the head, you see something very different. You see a very amphibian-like thing with a flat head with eyes on top. It gets even better when we take the fin apart. When we look inside the fin, as in this here, well, you'll see it as bone.
Look at this.
Compared to our shoulder, elbow, even parts of wrist, bone for bone. So you have a fish at just the right time in the history of life that has characteristics of amphibians and primitive fish. It's a mix.
And
very
just
nice.
As evolutionary theory predicts, Tiktaalik suggests a tree of life, with one species giving rise to another over millions of years.
Yep.
The discovery of Tiktaalik was still being written up at the time of the trial, so it couldn't be used as evidence. But Shubin's colleague, paleontologist Kevin Padian,
and I spoke with Kevin last week. No promises. Not going to put him on the spot, but Kevin said, yeah, he might be interested in appearing here in a little interview about his part in this trial, his story as a paleontologist, all that good stuff. So I need to email Kevin pretty soon to ask him about that. But yeah, he lives here in the Bay Area. I just saw him last week. Kevin's a good guy, and I think you guys are really gonna like him.
Showed the judge examples of other fossils with transitional features that support Darwin's tree of life.
My testimony in the trial,
there's Kevin,
was basically taking a day and showing the judge how we do our work and what the evidence is.
How dinosaurs evolved into birds, as seen in creatures like Archaeopteryx, which has a long tail and teeth like a dinosaur, but feathers just like a modern bird. How ancestors of modern reptiles evolved into creatures now extinct that share a common ancestor with mammals.
Yep.
And how surprisingly whales evolved from large land animals that returned to the water.
Mm-hmm.
And where the pandas book says we can't go from A to B, there are no fossils and we don't know how to study them. Actually, we've gone from A to B and to C, D, E, F, and G. We have the fossils, we have the transitional features, we have the ways of analyzing them with many different lines of evidence, and we're looking for the picture that accounts for the most lines of objective evidence.
Yes, indeed.
With each fossil, Padian refuted Panda's claim that different life forms appear suddenly by showing how fossils of extinct organisms bridge the gaps between species, resulting in a picture of gradual evolution, just as Darwin proposed.
The reporters in the courtroom were just amazed that we knew all this stuff, and how come they hadn't learned about this stuff before? And the reason is, it's not in textbooks because the creationists fight so hard to keep it out. That's been a big influence.
The court.
Yep. Yeah.
Took a break, and I remember the judge saying something like, biology class adjourned, for lunch. And he was, smiling, and it was clear that we had the judge interested in science.
Yeah. Anyway, we'll be watching this whole documentary, piece by piece, with plenty of commentary by me. In 2 weeks, I believe. Today's what, the 13th? 2 weeks. We'll be talking about that. And we'll be printing our Tiktaalik here. Very excited about that. Yeah, was science on trial? Sort of, freelancer. And spoiler alert, science won. We'll be talking about that. And maybe we can even bring Kevin Padian onto the stream. No promises, but that would be really awesome. I'll see if I can do that. So yeah. Yeah. And I've still got my mod comments from when we talked about this last year saved. I've got those at the ready. Thank you, Lenina. It will be... There's a potential for kind of fraught discussion about this because it deals with some controversial topics. You're dealing with religion, you're dealing with politics a little bit, you're dealing with some people's, like, very dearly held beliefs. The thing is, this is a science broadcast. Now we're here talking about science. How do we test ideas about how the world works? And no matter what kind of opinion or religious belief you might have, if you are committed to the idea of truth, if you want to know what is true and reject what is false, you should have no issue with that. Science is not your enemy. Regardless of your religious beliefs, if you're passionate about truth, you're going to have a good time in that stream and you're going to learn something, and we're going to uncover the beauty of the natural world together. I hope you'll join us for this. That'll be a lot of fun. So yeah. 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 Anyway. Yeah. Sculpin says some view facts as an enemy if it does not fit their views. well, they, unfortunately, or maybe fortunately, they can go take a hike. Maybe they need the exercise, you know? Afuera. En la basura. Into the garbage. If whatever your worldview is doesn't comport with reality, maybe you ought to consider that a little bit. Maybe take some pieces of that, throw them in the garbage. You know? Join us all in the light. And celebrate with us what we've been able to learn about the natural world. You know? Anyway, we'll be talking about that more in a few weeks. So yeah. Yeah. Good stuff. Printing our Tiktaalik right now, but you know what? There was another item that we finished printing, well, this morning, that I'm very excited about. We were printing part of a Psittacosaurus yesterday, weren't we? I've not only finished printing this, I've also 3D printed it. And I am excited to show it to you now. Ooh, let's get this out. Psittacosaurus lugiatunensis has finished printing. This is a dinosaur that was in the news this past summer, being attacked by a mammal. I don't necessarily buy that, but whatever. Yeah. Let me find this dinosaur for you right here. Psittacosaurus lugiatunensis. Yeah, ignore the weird bristly things. That's a better one there. Yeah. Psittacosaurus means the parrot lizard on account of that almost parrot-like beak and these big, another prominent feature, these big jugal spikes on the sides of the animal's head right here. Yeah, look at those jugals, Claire Burr. Incredible. Yeah. What a neat animal. Psittacosaurus. I'm excited about this. I really am. Take a look at that. Yeah. It's funny because this is an animal that would have been able to see straight in front of it. So some people say, oh, you know, prey animals, they can't see directly in front of them. They can only see to the sides, you know? That's not always true. That's not a good, hard, and fast rule. This is a plant-eating dinosaur that could see on either side of its head like this. It's got this lovely parrot-like beak in the front. Yeah. What a cool critter. And again, there's a nice reconstruction right there, except for the quills on it. That's a lovely one, too. Look at those little babies, except for the quills. Ignore the quills. Anyway. Here, let's take a look at this right here.
At some point, we've all wondered what dinosaurs actually looked like, especially their color patterns. Were they solid, striped, dappled, covered in polka dots? Many people thought we could never know for sure, but research published this week revealed what might be the most accurate dinosaur reconstruction ever made. And
except for the quills.
particularly well camouflaged for life in forests. The specimen was an extremely well-preserved fossil of Psittacosaurus, with pigment-containing structures called melanosomes that gave clues to the dinosaur's coloration. And the researchers, led by Jakob Winter from the University of Bristol, wanted to bring it to life, though not like in a Jurassic Park kind of way. They recruited a paleo artist to construct a life-size
Bob Nichols,
color
good stuff.
model of Psittacosaurus using careful measurements of the fossilized body and pattern of melanocytes. Overall, the dinosaur was darker on top and paler
Beautiful.
underneath, a classic case of countershading or 3D camouflage. The way that light falls on objects affects how we know what we're looking at. When they're lit from above, 3D objects look palest on top, since more light bounces off and into our eyes. Meanwhile, the underside has darker shadows. Many animals, including humans, are instinctively pretty good at noticing 3D things, like other animals, based on the way that light bounces off of them. But when the sun's shining, an animal with countershading, darker on top and lighter underneath, looks more evenly colored and doesn't stand out as much from its background. So 3D camouflage has evolved in lots of animals to stay safe from hungry predators, but the exact pattern of countershading depends on their habitat. Animals living in bright open areas like a savanna tend to have abrupt countershading, for example, while the diffuse lighting of forests favor a gradation.
Why not show a deer in a forest? You're showing a deer out on the plains. God, this editing.
Knowing this,
Not ideal.
researchers wanted to use their Psittacosaurus model to understand where it might have lived. To figure it out, they took pictures of a solid gray copy of their model in different...
And shoot, this is, we can find the video of this on YouTube. This is super cool. Counter shading. Here we go. Yeah, this is a different dinosaur, Sinosauropteryx, but this explains the idea of counter shading. Right there. This guy here is Psittacosaurus right here. Yeah. Very relevant. Let's watch.
Revealing what color dinosaurs were was once thought impossible, but the discovery around a decade ago that some pigments...
That's probably Bob Nichols painting that right there.
...has allowed us to reconstruct the likely color patterns of certain dinosaur species. One of the best places to find pigments preserved in dinosaurs is the early Cretaceous G-hole biota of China.
Yep.
Discovered here in the mid-1990s, Sinosauropteryx has feathers preserved that retain remnants of the original pigment that gave the animal its color in life.
Very cool stuff.
This means that we can reconstruct its color patterns to give a better understanding of how it may have behaved and to tell us more about the environment in which it lived. One of the color patterns seen on Sinosauropteryx is that it had a dark back and a light underside. This is a kind of camouflage called countershading.
Oh yeah.
It works because in the daytime, sunlight comes...
Well, and let me scoot this up here so you can see it better. In the daytime, sunlight comes from above.
Meaning that the top surface of an object is illuminated, while the underside is shadowed. In seeing this, our brains are able to recognize things as three-dimensional objects.
Yep.
In countershaded animals, the top surface is darker and the lower surface is lighter.
So this basically, animals that have evolved counter shading evolved a certain kind of defense against this, where they just want to fade into the background. They want to look as drab as possible and just kind of go fade into the background like that. They want to become as inconspicuous as possible. So they're going to be dark on top and light underneath, because your typical object, evenly shaded or evenly colored, will be light on top and dark underneath. So they're kind of yin and yanging it, you know? They're taking the yin yang and they're going zoop, and they're rotating it to become less noticeable.
This evens out the effect of shadowing.
See that?
Counter-shaded animals appear less three-dimensional.
Does that make sense?
Benefit for both predators and prey.
Yeah.
Importantly, lighting conditions vary between different types of habitat. Animals living in open areas with lots of light tend to have a sharp, dark-to-light transition high up on the body.
There's a pronghorn there.
Living in closed areas,
there we go. That's better. So here's a deer in the shadow, and it's got the darker part that goes further down like that. The transition is lower on the body in animals that live in forests.
Tend to have more gradual transitions positioned down. This means that we could determine the likely habitat that Sinosauropteryx was living in 130 million years ago.
Oh yeah.
Based on its pattern of countershading. To determine in which environment the countershading in Sinosauropteryx would have been most effective, we made three-dimensional models of its body, and observed them under varying light conditions. This showed us exactly where shadows would occur in each different habitat. We then compared that to the actual colour patterns seen in the fossils. The countershading transition was abrupt and high up on the body, best positioned to negate the shadows cast by direct sunlight.
An open area.
Infer that Sinosauropteryx was best suited to have lived in an open environment.
Very nice.
With this work, we have shown that by looking at paleocolour, we can start to understand important aspects of the behaviours of extinct animals, and also better interpret the long-lost habitats and environments in which they lived.
Very, very cool stuff. Yeah.
Outdoor environments to see how light would have fallen on the dinosaur's body. Then they
Yep.
used computers to compare these photographs with the observed counter-shading from the fossil to see which environment would have helped the dinosaur blend into the background. What they
Cool,
found
right?
is that Psittacosaurus was most likely adapted for forest life. Just like forest dwellers today, the counter-shading pattern produced by the dinosaur
Little forest dinosaur.
probably subtle, so
Yeah.
it dark to light fairly low on its body. The fact that counter-shading evolved at all means some predatory dinosaurs may have had vision similar to current animals that hunt. And the researchers hope that more well-preserved fossils will help them paint a more complete picture of how dinosaurs looked and how they saw the world. Now, as far as predatory
Pretty cool. And he's going to talk about snails now. That's not what we're talking about now. So long for now, Hank Green. But here's a link to that video. There you go. Yeah. How cool is that? Humans are so clever. It's pretty neat, Okami Kuma. It's pretty neat. So this animal, Psittacosaurus, we will surely have more research about this animal published in the nearish future. We'll be talking about it more, I'm certain. It's a cool dinosaur, Psittacosaurus. It's very cool indeed. So, yeah. Really happy to have a 3D print of this critter. And our Tiktaalik 3D print also going very well. What's the problem with the quills? Oh, yeah. You know, I'm sure if we were to go back into the VODs, like on YouTube, I could find you a clip of Jim Kirkland talking about this, but Jim Kirkland, state paleontologist of Utah, he is completely against this idea that these animals had quills on their tail like this. There's a specimen of Psittacosaurus that has been interpreted to have had a quill-like filament thing coming off of the tail like this right here. Here's the thing, as Jim says it. I'll try and relay this as best I can. As Jim tells it, there are literally hundreds of specimens of Psittacosaurus found like this. Many, many, many of them with skin like this. Preserved skin. This, like, brown stuff here is the skin. That's skin right there, preserved. This is a specimen that is currently in Europe somewhere, either Italy or Germany, I don't really remember. But this is a specimen that was stolen from China. It was smuggled illegally out of that country. And there have been a number of studies done based on this specimen. But there's these, like, weird bristly things here. Apparently out of hundreds of specimens from the same quarry in China, not one of them has this. Only this one, which was smuggled illegally out of the country and now resides in Europe, has these bristly filaments here. Jim thinks that these are not actual bristles or anything like that. He thinks this is a plant that the animal was preserved next to. Because none of the other ones have this. And so, I don't know. You know, I don't have a horse in this fight, so to speak. But Jim is adamant these are not real. Like, this is plant material, which sometimes gets preserved along with these animals. So he doesn't think they had quills at all. Time will tell, I suppose. And apparently, Jim says, yeah, if you look at any of the reconstructions from China, the Chinese never reconstruct Psittacosaurus with quills because none of their specimens show it with quills. So yeah. Yeah. Is that Xu Xing right there? With his Psittacosaurus there? Yeah. So anyway. Time will tell who's right about this. Did Psittacosaurus actually have quills? I'm siding with Jim about this right now, but you know, who cares what I think? I don't work on these animals. I'm not a ceratopsian guy yet. So yeah. Yeah. Anyway. Yeah. And are the others equally well preserved? Some of them better preserved, I've heard, Charlie's Dragon, but we'll see. We'll see. This is the thing. In science, many things are tentative. You know? We're dealing with limited information. We need more people out there finding fossils. Yeah. So we'll see. We'll see what happens there. With good old Psittacosaurus. Lugia tunensis. Yeah. But it's honestly so cool to have a 3D printed skull of this animal. Super excited about that. And I will be painting this before too long. Man, I gotta get some more spray paint. Yeah. So yeah. Yeah. Anywho. With that having been said, yeah. Here. Here, one more quick video about Psittacosaurus. I'm going to go run and use the little paleontologist room in the meantime. You stay here. I will be right back. Talking about how to infer color of extinct dinosaurs. Super cool.
Usually when we find fossils, we only have the hard parts removed.
Too quiet. Let me turn that up.
Tell us something about the shape and size of these extinct animals. But what they don't tell us is how they might have appeared, such as, for example, what colors they might have. The Natural History Museum's got vast collections of fossils, including feathers. And we have looked at these and found well-preserved pigments in them, which has meant that we could reconstruct the original colors.
There aren't loads and loads, but what we have got are really, really nice. I think the best ones are in here.
Right. Ah, look at that.
These are mostly from Europe, but there's a couple from America there.
We take the specimens and we look at them under a very powerful type of microscope that is called an electron microscope. And with that we can zoom in onto these impressions in the rock, and then what we see are the preserved pigments, little structures that are called melanosomes, and they are the structures that give colors to these fossils. While we know a lot about this Psittacosaur because we have many fossils, we knew nothing about its color. But because we have some fossils that do preserve the skin, we were able to carefully reconstruct its color patterns. The Psittacosaurus is a small herbivorous dinosaur. It's about the size of a Labrador. It's got a beak and horns on its cheeks, and mostly it was walking around on 2 legs.
Did he say it's about the size of a leopard? Everyone knows how big a leopard is. Oh yeah, you know, I go down to the corner market, I see leopards every day, you know?
Let's protect our fossils, because if they're removed, America loses them forever.
And Hazanku, thank you for continuing that gift sub you got from Jody Fish. Thank you kindly for your support, Hazanku. I really appreciate that. Thank you, thank you. Yeah, and a Labrador. He said Labrador? I heard leopard. Let's go back.
All herbivorous dinosaur. It's about the size of a Labrador.
Oh, Labrador. Okay. You might encounter a Labrador on your way to a corner market. You probably will not encounter a leopard unless you live on the Serengeti or in India. But yeah, Psittacosaurus, it's a lovely little critter. Yeah. Here we go.
This little fella is a Psittacosaurus. Thanks to a number of recent findings, we were able to restore this creature to a high degree of genetic accuracy, right down to the quills and coloration in some of its species. Just looking at its face, you might not realize that this was one of the first ceratopsians. It may lack a frill and forward-projecting horns, but you can still see the resemblance in its strong beak and its cheek horns.
There you go.
Just like other ceratopsians, Psittacosaurus is a herbivore, but its sharp beak and simple jaws are better suited to tough plant material such as nuts or seed. A word of advice, though, be wary of that beak. They're a little nippy. Now this little fella...
Psittacosaurus. So yeah, shoot, I failed to mention this earlier, but this is one of the early ceratopsian dinosaurs. So like you've got Triceratops and Navajoceratops and Styracosaurus there in the emotes. Here, let's do those again. Gablamo. Yeah. This is an early member of that family. You can see that beak in the front. You can see those jugal horns, jugal spikes. Later on, some of the, well, this is not actually a direct ancestor of the ceratopsians. It's a separate branch, which Jim Kirkland would be quick to point out. But this is a descendant of the same ancestors that later gave rise to critters like Triceratops, Styracosaurus, Navajoceratops, etc. Very cool. And just look at that face. Look how earnest. Looks like something straight out of Jim Henson's Creature Workshop.
It's got a beak and horns on its cheeks, and mostly it was walking around on two legs.
Yeah.
We've really removed as much speculation as possible. So we've taken all the information from the fossil, and we've allowed that...
And there's Bob Nichols himself, paleo artist.
What dinosaur we sculpt. And we've done that not just with the anatomy, but also with
Very
this colour
cool.
pattern. And we're going to then take it into the field and learn what we can from that.
And Rat Acid says, looks like someone just said walkies to it. Oh man, this dinosaur wants to go out on a walk with you. Absolutely. Just don't stick your fingers in its beak, you know? Oh man. Yeah.
And we've done that not just with the anatomy, but also with this colour pattern. And we're going to then take it into the field and learn what we can from that information.
There you go, Kami. Yeah. Yeah. I would take this dinosaur for a walk
It's
too.
brilliant now to have this model of the dinosaur and have these color patterns reconstructed onto it, because now it starts to paint a story of how this dinosaur might have lived.
Yeah.
And you can see that like the kind of counter shading that you have here, this light underside, really sort of mixes well with diffuse light.
Look at this critter. My goodness. Does look very eager to go out for a walk with you, right? Yeah. Yeah. Psittacosaurus. In fact, this is our same species of Psittacosaurus that I have right here. Psittacosaurus lugiatunensis, I believe. The funny thing about Psittacosaurus, normally when we're talking about dinosaurs, we don't have to be explicit about which species we're talking about. If you're talking about Tyrannosaurus, you're probably talking about Tyrannosaurus rex. If you're talking about Velociraptor, you're talking about Velociraptor mongoliensis. If you're talking about Torvosaurus, you're talking about Torvosaurus tanneri. Well, unless you're talking about Torvosaurus guernii. Anyway, it might be the same animal. Psittacosaurus, on the other hand, is the most speciose of dinosaur genera, non-avian dinosaur genera, I hasten to add. There are something like 20 different species of Psittacosaurus that have been named. Here, let's talk about that for a minute. There we go. Psittacosaurus. Other species. List of other species. Psittacosaurus sinensis. Myelingensis. Xinjiangensis. Satarayaki. Mongoliensis. Orodosensis. Mazongshanensis. Sibiricus. Lugia tunensis. That's our critter right here. Gobiensis and Amitabha. I'm pretty sure Psittacosaurus is the dinosaur genus with the most species named from it. Here's the holotype of Psittacosaurus mongoliensis right here. Here's a reconstruction of Psittacosaurus sibiricus. Yeah, Psittacosaurus myelingensis. Anyway, there could be actually multiple genera of animals here. But, yeah. Soft tissue and coloration. Interesting stuff. It's a cool dinosaur. Psittacosaurus. And, this is our taxon right here that we have printed, but some of these might actually turn out to be the same thing. Some of them are represented by critters at different times and different places. I don't know enough about Psittacosaurus off the top of my head to be able to tell you which species are valid and which are probably not, but yeah. Anyway, it's a cool critter, Psittacosaurus. And how you doing, Ken? Welcome, welcome. It's good to have you here. Welcome back, Ken. Psittacosaurus. Yeah. Were they always wandering off into different regions and speciating there? We don't really know yet, Golganek. There could even be like multiple lineages of this animal in different parts of the world. Maybe they're not particularly close to one another. We need more study of these critters. It's funny, I feel like with dinosaurs, there's often a tendency to oversplit them. Where you've like got different genera. You know, it's like, well, are they really different genera? They're probably just different species or chronospecies or different ontogomorphs of the same animal.
Wreaking his prehistoric fury on modern man and his puny machines.
Moran, thank you for the follow. Welcome to Paleontologizing. Good to have you here.
Ontogeny.
But with Psittacosaurus, maybe there's been some overlumping of Psittacosaurus. Maybe we've actually got multiple genera of dinosaurs here that have been divided up into all these different species. There are more species that have been named of Psittacosaurus, I think, than any other dinosaur. Let's see if the Wikipedia article has anything to say about that. Yeah. It is notable for being the most species-rich non-avian dinosaur genus. There you go. Yeah. What did I tell you? And was it just that this animal evolved really fast and diverse? No. This is like, I don't buy that. There's been a weird history to the study of this animal, Psittacosaurus, and that for whatever reason, maybe it's just got a skull that's like, you look at it and you go, oh yeah, that's Psittacosaurus. there are probably going to be multiple genera of this animal. They probably stretch across a pretty wide time. So yeah. Anyway. Yeah. Shoot, it's done from China, Mongolia, Russia, and Thailand. Yeah. Anyway, if you'd like to learn more about this critter, holy cow, this is a long article with lots of beautiful references here. Here is the article on Wikipedia. Yeah. Let's get back to look at that face there. Holy moly.
And you can see that like the kind of counter shading that you
And SV Harkin, happy birthday.
Underside
welcome.
Really sort of mixes well with diffuse light that we get here. It's quite clear that this thing would have been blending in really, really well with the background. We could see that it had evolved to conceal itself. It was camouflaged. It tells us something about the pressure that it was under back 130 million years ago. We know from the same deposits that there were fossils of tyrannosaurs, large carnivorous dinosaurs that probably would have eaten this poor little dinosaur. This remarkable discovery are giving us a wealth of information from these extinct animals. We're now bringing dinosaurs back to life in Technicolor.
Pretty neat stuff. Yeah. Pretty neat indeed. So yeah. You found a spot without grass to put it on though? Yeah, good for him, Charlie's Dragon. Yes, indeed. Good stuff. Now, Psittacosaurus, I'm sure we'll be talking more about that critter in the future, especially when I get this painted. Like we'll be talking more about Tiktaalik once I get that fully printed. Ooh, this is looking exciting right now. Good stuff. And Emeleth says tigers also have light-colored bellies, but no one's eating them. No, that's the thing, Emeleth. Counter shading works if you're prey or predator. It's something that's kind of universal. Here, let's take a look at this.
Hi, I'm Lisa Dilworth, an aquarist here at Mystic Aquarium, and here's your 60 seconds of science.
60 seconds of science. Let's get into it.
Today's topic is counter shading. Counter shading is a method of camouflage where animals are darker on top and lighter on the bottom.
Yeah, and you don't see, guppies or clownfish swimming up and taking bites out of sharks like this. This is a white tip reef shark. Is that right? I see a white tip there on the dorsal fin. They've also got counter shading. The thing is, if you're a predator or if you're prey, it still behooves you to have counter shading because it makes you harder to see. It makes it harder for predators to see it, makes it harder for prey to see you. Everybody wins or loses.
An example of counter shading can be seen on this stingray. As you can see, the stingray is dark on top and light on the bottom.
Okay.
When viewed from above, it blends in with the dark surrounding ocean floor. When viewed from below, it blends in with the brightly lit surface. Counter shading isn't just seen in aquatic animals.
Nope.
It can also be seen in terrestrial animals as well, such as reptiles, insects, and...
I'm sorry, what? What? Did you catch that, chat? Did you catch that?
terrestrial animals as well, such as reptiles.
Reptiles? Oh, boy. That, ladies and gentlemen and NBs, is a red-eyed tree frog, which is an amphibian. It's a frog. a member of Lysamphibia. It is not a reptile. Oh, boy. Unfortunate. Yeah. Bad editor. Bad. Exactly, Lenina. Yeah, not great. Not great.
Insects and birds.
Yeah, but if she had said reptile and showed this, that would have been close. You know, birds are a kind of reptile because they're descended from dinosaurs who are a kind of reptile. Birds are reptiles, folks. Frogs are not.
I hope you enjoyed this 60 seconds of science.
Wasn't my favorite. Yeah. Anywho. Not ideal. But anyway, lots and lots of predators also have counter shading. It's not just prey animals. And that's also like a false dichotomy, predator and prey animal. The majority of animals around that eat other animals are also eaten by larger animals. I guess tigers would be an exception. There are very few animals that eat tigers. There are very few animals that will kill and eat a tiger. You know, I suppose crocodiles would do that. Maybe certain species of shark, if the tiger is swimming across ocean water. But for the most part, tigers don't really have to worry about that kind of thing in the wild. So you could think of them as a predator, but most animals are both predator and prey, you know? So yeah. What about worms, says Claire Burr? Well, they're not really counter-shaded, so they live under the ground. But yeah. And tigers murk brown bears and grizzly bears too. Yeah. Amur tigers will actually eat not grizzly bears, sorry. Asiatic brown bears. Yeah. But then every once in a while, a brown bear will also probably kill and eat a tiger. On rarer occasions, but it still happens. You know? Nature is messy. There's full of gray areas. There's weird stuff. Not weird stuff. There's, you know, there's a lot of interplay going on. Nature doesn't like to abide by these neat little boxes that we try and stuff it into. It just doesn't really work. So yeah. Anyway. Yeah. 55 seconds of science and 5 of... No! That's not an amphibian. There you go, Golganek. We probably did that for more than 5 seconds, but yeah. You're right. Yes. Yeah. Yeah. Anyway. Good stuff. But anyway. And Charlie's Dragon says... Oh wait, no, somebody was talking about cows? Patrick Crusader says cows. I hear cows are more dangerous than sharks. Yeah, because if you eat too much beef, you can get colon cancer. Pretty easily. Patrick Crusader says, I hear cows are more dangerous than sharks. Because maybe they kill and eat a lot of tigers. Wait, what? Cows do kill more people than sharks do every year. Living cows will do that. But, pigs also. Pigs in particular are deadly. Yeah. Shoot, let's talk about this. Is this going to be any good?
News is brought to you as everyone thinks. We've got a list of animals way deadlier than sharks, and some of them may surprise you.
Yeah, sharks are just... It's kind of funny because sailors a long time ago referred to sharks as sea dogs. And they kind of are just the dogs of the sea. Although sea lions and seals also you could refer to as dogs of the sea. But anyway, don't be super scared of sharks. They're less likely to kill and eat you than, say, a pig. Yeah, a few good taters, welcome. Good to have you
Kara
here.
here for D News, and I'd be lying if I said I wasn't petrified of sharks. With their tiny, beady eyes and layers upon layers of sharp teeth, they're terrifying. But you know what? In the grand scheme of animals that
Rows of teeth,
sharks
but whatever.
are actually pretty low on the list. Only a
Yep.
handful of the over 375 different shark species are known for attacking humans. And while the world sees anywhere from 50 to 70 shark attacks a year, less than 20 of those are actual fatalities.
There are, I think, more people who are killed by vending machines every year than by sharks. There's another statistic which I don't think is true, that more people are killed by falling coconuts every year than by sharks. I don't think that one's true. Vending machines, yes. Pigs, yes. Pigs kill more people every year than sharks do. I think cows do also. Dogs certainly do. Domestic cats probably do too.
So clearly, sharks are getting a bad rap. There are animals out there that are way cuter and kill way more people every year. Elephants, for example, kill almost 500 people a year, which makes
Wow. That's actually kind of impressive. Like, respect.
them 10 times more dangerous than sharks. And the fact that they're the largest land mammal means they can easily crush someone with their weight. They're also known
Yep.
to exhibit unpredictable behaviors and attack people without warning, especially during reproductive season. The same
Yeah, I can relate. And I laughed at the story where divers trained the shark to bite them in the tush. I never heard of this story, Rizadegu. I never heard of this story. What? And yeah. Indeed. Shoot, I don't know if I'm gonna be able to find this. Yeah. Anyway, I'll show you that clip in a minute. Let's continue.
Same goes for hippos, another adorable animal that seems harmless but is actually super deadly.
No, hippos are extremely dangerous animals.
Deaths every year.
Holy cow, almost 3,000 people every year killed by a hippopotamus. Oh boy. Yowza.
More people in Africa than any other large animal. They're a naturally aggressive and territorial species, and you might not think it, but they can run up to 20 miles per hour, faster than a human, with jaws that open 4 feet wide and clamp down like a sledgehammer. They could literally
Yeah, holy cow.
chase down a baby and eat it, which is ironic because baby hippos are one of the cutest things on earth.
It's true, yes, but hippos are... They have been known to literally bite people in half. Here, take a look at this. That's a watermelon right there. Just eaten like it's a gusher. Oh my goodness. Yeah. Hai agemasu. Hippopotamus. Oh my goodness. It's a literal fruit snack, Claireberry, yeah. Imagine that were your skull, you know? Yep, there are recorded instances of hippopotamus killing people like that, just basically biting them in half. It's pretty wild. They get territorial. They get aggressive. If you go there into their home, they might mess you up. You know, if you get too close, they will show you who's boss. Stay out of their home. You know. Casual Geographics? I've never heard of this, Ken. What? There's no swear words in this, right? Oh, I've seen this guy before. Shoot, but not PG. Okay, thank you, Charlie's Dragon. Yeah, yeah. I've seen it. He's on Tink Tonk as well, right? Or something? Yeah. Anyway, good stuff. I don't think I can share that on stream, but thank you, Ken. Anyway, something that is much more likely to end your life. The humble vending machine. You know, much more likely than a shark to end your life. Probably more likely than a hippo, too. Well, I don't know. Maybe not. And he was never heard from again. The death of Homer Simpson. No, it doesn't actually end that way. Mm. What? Anyway, yeah. I was looking for that 30 Rock clip. But I don't know if I'm gonna be able to find it. Shoot. Yeah. Darn it. Oh well. That's okay. There was a 30 Rock clip that also dealt with the danger of vending machines for the unwitting. How many people are killed by vending machines every year? It's more than sharks, I'm pretty sure.
So cute. Crocodiles, but they're still deadlier than sharks. They're the largest reptile in the world with the largest bite force ever measured, up to 3,700 pounds of pressure per square inch.
That's the saltwater crocodile that did that. The Crocodilus Novo. I forget the species name, but down in Australia, they refer to it as a salty. Salties. The crocodile that you most want to watch out for. They kill more people every year than boomerangs or didgeridoos.
People have actually been eaten alive by crocodiles. And while the American ones aren't really known for their aggressiveness, there are certain species in Africa and Asia, like Nile and saltwater crocodiles, respectively.
Nile crocodiles do not live in Asia. They live in Africa.
Girder.
Saltwater crocodiles live in both Asia and Australia. What?
There are certain species in Africa and Asia, like...
Oh, wait, no, she did say Africa and Asia. Never mind. Sorry. Apologies. My bad. She got that right. I misheard her.
Nile and saltwater crocodiles, respectively, that attack up to 1,000 people every year. Which begs the question, why do people still go in lakes and rivers? Nothing good can come of that. You have no idea what's in there. Snails?
I mean, what about some, fluvial fun there in a river, or lacustrine fun in a lake?
Maybe? Those seem pretty harmless, right? Nope. Freshwater snails kill up to 200,000 people every year.
Holy cow.
Schistosomiasis, a parasitic
Oh,
worm
boy.
that snails release into fresh bodies of water. Anyone who comes into contact with that water, especially people in poorer nations, can contract it. And once it gets into your veins, it makes its way to your urinary tract and your intestines, laying eggs and causing lifelong problems, including death. It may
And shoot, this actually reminds me, just last summer, not this past summer, but the summer before, I had a weird, rash on my back that I looked up and I was able to figure out was called swimmer's itch. And that occurs when snails in,
Have a moment where it was kind of heartbreaking? I'm
No.
destroying, never.
No, glue is cheap.
Thanks for being my favorite new streamer, Paleodance.
Thank you, Emeleth, for being my favorite new subscriber. I appreciate you, Emeleth. Thank you for your ongoing support. 2 months. Thanks for keeping me here on the air. I appreciate that. Good stuff. Yeah. Yeah, shoot. Here, take a look at this.
By Brilliant. Summer has ever included cooling off with.
This is something that I got last summer after swimming in the Colorado River while out on a dinosaur dig. Ugh.
Swim in a lake. You might be acquainted with something called swimmer's itch. These itchy red
Ugh.
bumps appear on the exposed parts of your skin after you take a dip in a lake or pond, and they can last for a week or more. But swimmer's itch is more than just an annoying rash. It's actually caused by parasites that burrow into your skin and then die there.
Yeah.
Glue is cheap.
The culprits are tiny worms called schistosomes. Each schistosome species
Yeah.
specializes in a specific bird or mammal host. Some schistosome species target humans, causing a debilitating disease called schistosomiasis.
I didn't get that, thankfully. At least I don't think so.
Swimmer's itch aren't after you. They're part of
Yep.
a different group of species.
So they're going after dinosaurs, actually. Waterfowl, specifically.
Whose hosts include ducks, geese, muskrats, and raccoons. That
Oh,
itchy
and some
rash is
mammals,
what
too.
happens when one of these schistosome larvae makes a mistake. Adult parasites live in their host's blood, and when they lay eggs, the host eventually poops them out. With a little luck, the eggs end up
Ugh.
in water, where they hatch
Grody.
into larvae that swim around in search of the aquatic snails that they need to infect to complete the next stage of their life cycle. The baby schistosomes
Oh.
continue to multiply and develop inside the snail. And eventually, the infected snail releases a second type of larva called cercarii into the water. This is where swimmer itch gets its technical name, cercarial dermatitis. These little guys,
Huh.
each less than a millimeter long, head out to look for a member of their original host species to start the cycle all over again. You'd think it would be easy to tell the difference between a human and a muskrat or goose or whatever, but sometimes the cercarii mess up and burrow into a human swimmer's skin.
Yeah, so I got a rash. It was like right here on my back. Actually, probably like up here, like that. And I was in the field. This would have been last July. Not this past July, but the July before. I was out in Utah, went swimming in the Colorado River with members of my crew. Came back, and like a few days later, I don't remember if it was Ethan or Fisher or who. They're like, Danny, is that a red Dorito stuck to your back? Like,
I'm here to applaud the
what?
work of vertebrate paleontologists.
And right on the body, thank you for the follow. Welcome to Paleontologizing. It felt like I had, or apparently looked like I had a red Dorito written on my body. And no, it was a rash with these like raised bumps caused by this.
It's a fatal mistake. They can't
Yeah.
get out there, and so they die. And because dead baby parasites are definitely not something
And there you go, Ken. Yeah.
in your body, they trigger an allergic reaction as they break down. That's what the itching
Yep.
and redness is from. Because it's an allergic reaction, some people are more sensitive than others. It just depends on how strongly your immune system responds. And if you're exposed to swimmer's itch over and over again, you can actually become more sensitive to it over time. You're
Oh,
most likely
shoot.
to get swimmer's itch in fresh water, but it's
Yep.
possible to get it in salt water too. So even at the ocean, you're not completely safe. To keep your risk small, towel off or shower as soon as you get out of the water, and don't do anything to attract.
Yeah, shoot. I didn't have a shower for like 2 or 3 weeks after that, so yeah, it was no showering out. That was our shower in the Colorado River, you know?
Birds that might host schistosomes to the area. That's right, no more feeding the ducks. It's a small price to pay to avoid parasites dying a slow, itchy death under your skin.
It wasn't that bad. It just looked weird.
Chances at the beach, maybe a mathematical game of.
Anyway, yeah. So yeah, that is... In other places where humans are actually the host, it will literally kill people, you know?
People still go in lakes and rivers. Nothing good can come of that. You have no idea what's in there. Snails, maybe? Those seem pretty harmless, right? Nope. Freshwater snails kill up to 200,000 people every year.
Holy cow.
Schistosomiasis, a parasitic worm that snails release into fresh bodies of water. Anyone who comes into contact with that water, especially people in poorer nations, can contract it. And once it gets into your veins, it makes its way to your urinary tract and your intestines, laying eggs and causing lifelong problems, including death. It may only...
Well, but death comes for us all. I mean, shoot. I hasten to add at this point that I have had swimmer's itch. Dinosaurs are kind of funny. Thank you once upon the sly for the follow and welcome to Paleontologizing. It's good to have you here. Look, I hasten to add here, do not let this scare you away from going into fresh water. Or salt water, or whatever. I always encourage people, especially here on Twitch, to go out, explore the world around you, go encounter nature. I had this, it was like a mild inconvenience, and then it went away, you know? That's a small price to pay for, you know, enjoying this incredible world around us. Especially on Twitch, I always try and encourage people to step away from the computer screen, go outside, and enjoy this incredible world that we live in. You know? So don't let this... I don't want this to be the sort of thing that scares you away from spending time outdoors, so please do not do that. Welper, thank you for the follow. Welcome to Paleontologizing. Yeah. Thanks for clicking that follow button. Oh yeah, yeah. Anyway, but Danny, it's dark outside. Wait till it's light, Araya. Wait till it's light. Or, you know, there's this wonderful invention. You know, we live today in the 21st century. Wonders of technology abound, including this thing called a flashlight. You can take this outside, or you can put it under your chin and you can tell a spooky story. Like, one time, there were a group of people just like those in chat right now. And they stayed inside all the time and never got to go outside and experience the wonders that exist outside of their computer room. Ooh, you know what I mean? So yeah. We should go swimming with a flashlight for light. I mean, maybe go swimming in the daytime first until you're more comfortable with it, Rat Acid, and then... Yeah. Anyway. Thursday Birds Day is tomorrow, everybody, and that is our day every week where we celebrate going outside, photographing birds, and we talk about them live on stream. So, I'm looking forward to everybody's Thursday Birds Day birds next day, tomorrow. Next day. So yeah, there you go, Birds Are Done. Yeah. Yeah. I don't know if I have a bird photographed. Shoot, I gotta get on that. Photograph myself a bird for tomorrow's Thursday Birds Day Thursday bird. Yeah. We'll take my phone next walk. There you go, Ice Allen. Yeah, there you go. Anyway.
But some reports say it affects
Snails.
240 million people worldwide, making it one of the world's most deadly parasitic diseases, second only to malaria. That's right.
Yeah, mosquitoes.
Mosquitoes are by far the deadliest. These little guys infect over 500 million
Whoa,
people.
whoa, 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 whoa. Hang on. What did she say that was incorrect? Oh, it's right here. You can see it in the captions. What's wrong with this, chat? What's wrong with these captions? What's wrong with what she said here? Yeah. What's wrong with this? If you said something like, it's not the male mosquitoes, not the guys that bite, it's the females. Ding, 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 you are correct. Female mosquitoes are the only ones that actually bite. In the same way that all of the worker ants and the worker bees, any bees that you see flying around, don't ever refer to them as he. Those are female ants there. Science Streams can tell you all about this. Go follow Science Streams if you're not yet doing so. He's a systems and molecular biologist. He works on ants. He can tell you all about that. Not that ants or bees or mosquitoes have the same, gender norms that we as humans have adopted in different cultures and everything, blah, 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 whatever. But anyway, if you want to be correct about this sort of thing, these little gals infect over 500 million people every year. Gals, not guys. So yeah. And Balint is on right now? Really, really? Let's go have ourselves a look. Yeah. There's Balint right there. Yeah. Science Stream's doing some... Oh, Wacom Wednesday. He's doing some digital art for today. Very nice. And guys and dude can be gender neutral, I suppose. Charlie's Dragon, yeah. Yeah. Fair. Fair. Anyway. These little gender neutral guys...
Little guys infect over 500 million people every year, killing almost 1 million worldwide. It's the Plasmodium parasite that lives in the saliva of mosquitoes and travels with your bloodstream after you get bitten. The classic symptom is repeated cycles of shivering cold, followed by intense sweating and fever. And if left untreated, it can lead to neurological symptoms, respiratory illness, and death. It's estimated that a child dies every 1 minute due to malaria in Africa alone. I bet sharks don't seem quite as bad now, huh? I mean, yeah, they might look scary, but at least you know you can avoid them just by not going into the ocean, and that's more than I can say for mosquitoes, nature's tiny silent killers.
No, actually, you could, well, the opposite. If you go into the ocean, you'll avoid mosquitoes. Mosquitoes famously do not do very well underwater in their adult form. But anyway.
Hopefully none of this has scared you out of any travel plans you may have, but if it has, no need.
Yeah, anyway. No ads here. The only ads here that you have to worry about are the ones that happen about once an hour and are a minute long that will arrive if you're not subscribed to the channel. So yeah. Yeah. Anyway. Yeah. Is it time now for a dinosaur deep dive? Listorian, thank you for that gift sub. I appreciate that, Listorian. Thank you, thank you. I believe we had a dinosaur deep dive request from Matt M33. Matt M33, are you here right now? Rebbachisaurus is a very interesting sauropod dinosaur. Oh, and thank you, Sculpin. Look, we're at 15 out of 40 new subs now.
Sculpin01 really wants ukulele with those 5 gift subs.
3/8? Hang on. 3 times 5 is 15. 3 times... Anyway. No, hang on. 5... 40, we're almost 1/3. Anyway. 15/40ths of the way there. What's each of those divided by 5? That would be 3/8? 3/8 of the way to our sub goal? That doesn't sound right. 3/8. It doesn't look right, though, Lenina. Yeah. Anyway, thank you, Sculpin, for those 5 gift subs. There are 5 people now who won't have to worry about any ads for the next 30 days. And one more from Listorian. Listorian and Sculpin, thank you for, thank you for your support. I appreciate that very, very much. Holy cow. Good stuff. And Matt M33, you are still here. Excellent. Let's talk about Rebbachisaurus right now. We'll do an ad hoc deep dive on this animal. So Rebbachisaurus is kind of a mysterious dinosaur. Yeah. Rebbachisaurus. It's, there's not a lot of images of this animal, honestly. Google wants to redirect it, correct it to Brachiosaurus.
Dinosaurs are kind of funny. I mean, you know.
Dinosaurs are kind of funny. It is true, Hobbies with Jose. Welcome to Paleontologizing. Rebbachisaurus, I think, is primarily distinguishable by its teeth. But let's look into this animal. Rebbachisaurus. There we go. It's from the late Cretaceous of Africa and possibly also South America? Oh boy. This is when you know that this animal is not particularly well known or there's a lot of mystery surrounding it. When it's possibly known from 2 continents? Remains attributed to Rebbachisaurus have been found in Morocco, Niger, Algeria, Tunisia, and also possibly Argentina, if Rheosasaurus is the same animal as Rebbachisaurus. Although only the Moroccan remains can be referred to this genus without doubt. Yeah. The discovery of Rheosasaurus, a South American sauropod nearly identical to Rebbachisaurus, which may have actually been the same animal as Rebbachisaurus, supports the hypothesis that there was still a land connection between Africa and South America during the early Cretaceous, long after it was commonly thought the 2 continents had separated. So interesting stuff. These are the vertebrae of this animal, Rebbachisaurus. Holotype vertebrae. We don't have a great deal known from this animal, do we? This is one of those critters that shoot, despite how commonly its name comes up, it's not super well studied or well known. So this is how much we actually have of the type species of this animal. We've got an almost complete vertebra, some fragments of other vertebrae, a scapula, part of a humerus, part of an ischium, and the dorsal spine of a caudal vertebra. Not a lot. Golganek, thank you for that gift sub to SV Harkin. Thank you, Golganek. Good aim there. It's a good recipient. Thank you, Golganek. A mysterious dinosaur. Sparse indeed. Yeah. Unlike your sub-goal record there, Golganek. Holy cow. Your gifted subs record. This dinosaur pretty sparse. Holy moly. Oh boy. Yeah. I wonder if we can even find a video on this critter. If any videos exist on the old YouTube. Rebbachisaurus. Not really. It's all Brachiosaurus. I think YouTube is also automatically redirecting. Oh boy. Not ideal. Look. Brachiosaurus, Brachiosaurus, Brachiosaurus. Search instead for Rebbachisaurus, please. Brachiosaurus. There's not a lot known from this animal. Shoot. But Rebbachisaurs are an interesting group of sauropods. They've got distinctive teeth. Yeah. Ugh, excuse me. There's honestly not a lot to say about this animal. Let's look at the original descriptive paper, I suppose. And it was described in 1954 by L'Avocat. Let's take a look at that publication, shall we? Yeah.
Like Big Daddy, I dig your vibration.
That's not the right one. I'm sorry, what? This is linking to the wrong article? Oh, okay, I see what would mean. Yeah. Honestly, not a lot to say about this animal. This is one of the few reconstructions you'll actually see of it. It kind of reminds me of like a Dicraeosaur. One of these long-necked sauropod dinosaurs with a fairly short neck, actually. So yeah. Yeah. This is a tricky one. Rebbachisaurus. Trying to do a deep dive on this is difficult because there's so little material known from it. And it's mostly known from vertebrae. I'm not a sauropod guy, so I can't necessarily walk you through all of the intricacies of these dorsal vertebrae like this and show you how they're different and paint for you a beautiful portrait of how these dinosaurs differ from one another just based on the anatomy of their backbones. This is not my specialty. This is a tricky one. It really is. Yeah. Let's just look at Rebbachisauridae real quick. There's Lemaisaurus, which is probably much better known than Rebbachisaurus there. There are an entire family of sauropod dinosaurs known from fragmentary fossil remains. They're from the Cretaceous of South America, Africa, North America, Europe, possibly Central Asia. This is probably one of your more mysterious dinosaur groups. Although Nigersaurus is one of these, and Nigersaurus has gotten some attention because of how incredibly weird it is. Maybe we can find a video about this animal, a member of Rhybachisauridae, the same family as Rhybachisaurus. Nigersaurus. Here we go. Take a look at this. From National Geographic. Nigersaurus. From the nation of Niger.
Position and shape of the muzzle as opening our eyes to the fact that there were dinosaurs that were in essence Mesozoic cows. We think about
Weird. It sounds like Paul Sereno here.
today mammals as the animals that naturally would
Look at the front of that snout. Hang on. Look at that.
that were in essence Mesozoic cows. We think about cows and animals that graze today.
You know what this reminds me of? Right here? Trying to find you an image here to explain what I'm talking about. Yeah. There we go. Yes. Nigersaurus right here.
Essence Mesozoic cows. We think about cows and animals that graze today.
There's its snout right there. This is what that reminds me of. Like one of the attachments for a vacuum cleaner nozzle. For just hoovering up all kinds of stuff across a plane like that. Again, there. And there. You see the resemblance? Yeah. Wild. This is a Rhybachisaur. Nigersaurus. Maybe a weird one. I don't know if we actually have a skull from any other Rhybachisaurs. Maybe they all looked like this. I don't know.
As the animals that naturally would fulfill this niche. It's a decade's worth of work, and when you put the animal together, you want it to be beautiful as well as accurate.
Oh, this is cool footage. Yeah. A fern cropper. Maybe sculpin. Maybe just eating horsetails or club mosses or something on the ground.
The bones sort of got dispersed in a field of fossils, and we're not sure which belongs to this animal, so we're not willing to say further.
Huh.
It is like nothing else that had been discovered.
Did all Rhybachisaurs look like this? Huh.
I made a design of the animal in my mind after I worked up all the lengths of all these bones, and I would have the fossils in front of me. I worked up a scheme for this dinosaur in lateral view and in dorsal view. And what I wanted to show was something about it. I wanted the bones to speak, to tell me something about its life, even though it's not going to move.
Tail goes off that way and then sort of snaps back.
So I wanted to create some
Look at that skull.
a little bit more involved than just movement and expression in putting this together. And when four-legged animals walk, particular limbs also move in particular ways. So I gave them a map, and I gave them the height, and I gave them the direction, and they did an incredible job.
Putting some ferns there. That's an interesting statement. Ferns, ferns. It's looking at the ferns. Interesting. Interesting. Yeah.
Here. I'm going to tell a story from the Mesozoic today, and for that we need a Mesozoic stage. That's
A
about
110 million year old dinosaur, dubbed the fern mower for its bizarrely shaped
Fern
mouth and
mower.
delicate skull, was unveiled at the National Geographic Society.
in the ground, extremely fragile.
The dinosaur, known as the Nigersaurus tecatai, was found in the Sahara by National Geographic explorer-in-residence Paul Serino, a paleontologist and professor at the University of Chicago. Serino had been piecing the dinosaur together since the 1990s.
This was an incredibly strange animal with a mouth that expanded like a vacuum cleaner, hundreds of teeth in the skull. It was probably taking cropping vegetation close to the ground. We were able to determine, it was very clearly something new.
The animal, which measured around 50 feet in length, sustained its huge size by mowing down mouthfuls of greenery using its featherweight skull armed with hundreds of needle-shaped teeth.
They weren't
dinosaur's
needle-shaped.
strangest feature was
Not a
broad,
good way to put
straight-edge
that.
muzzle, which allowed its mouth to work close to the ground. Unlike any other herbivore,
There you go.
Nigersaurus had more than 30 columns of teeth lined
What
up
a
tightly
wild
along the
snout.
front edge of its squared-off jaw. Even more unusual, CAT scans of the jawbone revealed replacement teeth stacked behind each cutting tooth. The animal had more than 500 teeth, with stacks of up
Look
to
at
10
that.
teeth in one line erupting from a single point in the jaw.
Wild. It really does look like a vacuum cleaner nozzle. I mean, it really, really does. It's pretty wild. And these are all, I assume they don't have the actual teeth here, not all of them in a row. These dinosaurs would be like constantly replacing their teeth, so there would be like gaps in this tooth row, I presume. They wouldn't lose them all at once, right? But yeah. More like a comb than a bunch of needles. There you go, thing, yeah.
In 1976 by French paleontologists, though the species was not named. Serino and his team honored this early work by naming the species after French paleontologist Philippe Taquet.
Yeah.
The Nigersaurus is on display at the National Geographic Museum in Explorers Hall in Washington, D.C. through March of 2008.
Cool stuff. Yeah. Nigersaurus, who is a member of Rabacisauridae. Our dinosaur deep dive on a Rabacisaurus. There's not much to say about Rabacisaurus, but Nigersaurus seems to be a member of this group. There's Lemaisaurus right there. From northwest Patagonia, Argentina. And this animal, of course, we have no skull from. So could all of these dinosaurs, the Rabacisaurs, have had a skull like Nigersaurus? It's a good question. I don't know. We need more fossils of these animals to figure out what's going on with these critters. They're really bizarre. So yeah. Pretty strange. What a weird group of animals. Truly bizarre. Yeah. Let's check on our 3D printer and see how that's going right now. Printing our Tiktaalik fossil. Ooh, this is going really well. This is in multiple parts. I'm happy about how this is going so far. Good stuff. Excellent. And Emila says, so it didn't have any chewing teeth. It did not. No. Most dinosaurs did not have chewing teeth. Our Allosaurus here. No chewing teeth. Swallowed its food whole. Deinonychus up here on the shelf, no chewing teeth. Tyrannosaurus, no chewing teeth. Dilophosaurus, no chewing teeth. Camarasaurus right here. Good example, no chewing teeth. Camarasaurus is a fellow sauropod. It's a member of the same major group as Nigersaurus and Rabacisaurus. And it does not have any chewing teeth. All of these teeth are for cropping vegetation, not for chewing. These animals swallowed their food whole. And that's probably one of the keys to their success, actually. They didn't waste their time chewing. They weren't adapted for that. They didn't evolve in that way. Instead, they gulped their food.
Let's protect our fossils, because if they're removed, America loses them forever.
Jayco, thank you for subscribing and welcome to Paleontologizing. It is wonderful to have you here. Thanks for that pledge of ongoing support. I appreciate that very, very much. Thank you kindly. Yeah. Good stuff. Here. Take a look at this right here, talking about Camarasaurus and other sauropods who did not chew their food. Rocky Coast Fog, how are you doing? Welcome, welcome. Yeah. There's Camarasaurus. Yeah. Oh, they were chewers. Dryosaurus chewed their food, but big Camarasaurus did not. Yep, look at those big, thick teeth right there. We're just cutting through those leaves and branches. There you go. Yeah. Yep, no chewing. The long-necked dinosaurs, no chewing. We don't know if this is true. Yep. Yeah. But these guys are able to get so large in part because they didn't chew their food. Because they could just gulp their food and consume massive quantities of it very quickly. They were able to get truly gargantuan. It's just a more efficient way of being able to do things. If you're going to be a super large herbivore, you don't want to waste your time chewing. You want to ingest as much food as possible as quickly as you can. That's exactly what they did. So yeah. Yeah. And that was John Goodman. Yes, indeed, Rizadego. He narrated When Dinosaurs Roamed America back in 2001. It's a long time ago. Unless you're looking at it geologically speaking, then it was indistinguishable from today. But yeah. Yeah, and Rockophile, hey, you've probably run already, but thank you for being here, Rockophile. Yeah. And what's the current thinking on gastroliths, Kennedy? It's still a matter of debate. Yeah. So here's a paper by Oliver Wings and Martin Sander saying that sauropod dinosaurs did not have a gastric mill. They did not swallow stones to grind up food in their guts. I'll give you a link to this. There is a general consensus, I feel, that is emerging today that the whole swallowing stones to aid digestion thing is not, that's not how it happened. Yeah. So part of that is they looked at the supposed gastrolith stomach stones preserved in sauropod bodies and found that they were they should be much more abraded than they are in the sauropod stomachs. So fast abrasion occurred in the gizzards of ostriches. They did not develop a polish. Instead, the stones were all scuffed up after rubbing against one another like that. They didn't get polished like in a rock tumbler. Also, relative gastrolith mass in sauropods. Gastrolith mass is less than 0.1% of body mass. Is at least an order of magnitude less than that in ostriches and other herbivorous birds. Also arguing against the presence of gastric mail in sauropods. Yeah. But gastrolith clusters in some derived theropod dinosaurs, Oviraptorosaurus and Ornithomimosaurus, compare well with those of birds, suggesting that the gastric male evolved in the avian stem lineage. So Oliver Wings and Martin Sander are suggesting here that sauropods, the long-necked plant-eating dinosaurs, whom you just saw in that video clip, did not swallow stones for digestion. But smaller dinosaurs probably did, because stones that have been found in their rib cages seem to match well with the stones found in modern ostriches and critters like that. So yeah. Johnny Fave, thank you for the follow. Welcome to Paleontologizing. Yeah. So yeah. Yeah. And Claire made something? What is this? Claire Burr. Look at this. Holy cow, Claire. That is really funny. Holy cow, Claire. I appreciate you. That is excellent. Is it okay if I post this to Twitter later? I like this a lot. I like this a lot, and I'd love to share it. Yeah, doing the heavy math. There you go, Kennedy. Yeah. Lovely. Let me save this right now, actually. Yeah. That is excellent. I'll see if I can post that tomorrow morning, maybe. Good stuff, Claire. Thank you, thank you. Wow. Well, I've got some stuff that I've got to do tonight. I've got some emails to respond to. I've got some science to attend to. It is about time, actually, that I start wrapping up this stream. I'm excited to show you more of our Tiktaalik once it's these parts are printed tomorrow. We'll be continuing more of it tomorrow, of course. And, yeah. Tomorrow is Thursday Birds Day. I've got to go out and photograph a bird before then. Yeah. But don't go away just yet, everybody. We're going to wrap things up, but we're going to raid into somebody else doing some science here on Twitch. Let's see who else is on. And, there's a Deinonychus. Skull to run our credits over. There we go. Who else is live right now? Let's see here. Cardboard Cowboy is on right now. Well, shoot, let's go say hello to Cardboard Cowboy. It's been forever since we've seen old CBC. Gonna go say good eye to Cardboard Cowboy. There we go. This is a stream for mature audiences, so be aware. But you're really gonna like Cardboard Cowboy, even when he is just doing video games. You're gonna like him a lot, I think. Anyway. Everybody, thank you for another wonderful stream. I hope you had a great time today. I had a good time. I hope you learned something. I learned some things. I, hope you had fun.
That's how dinosaurs are. Unpredictable.
They are unpredictable. Iocane, 26 months of support from Iocane Powder. Holy moly. Iacane, thank you very, very much for your ongoing support. That means a lot to me. It really does. Iacane is in the process of a big move across the country, I hear. I hope it's going well, Iacane. Anyway, everybody, thank you for another wonderful stream. Thank you for your support, your raids, your views, your questions, your subs, your gift subs, your cheers, your everything else. Thank you, thank you. We're going to go see what Cardboard Cowboy is up to. I'll see you there, everybody. And I'll see you tomorrow for Thursday Birds Day. Take care, everyone.